On October 10, 2025, the European Space Agency released an image that millions had been waiting for. Scientists, amateur astronomers, and conspiracy theorists alike had circled this date on their calendars. The ExoMars Trace gas orbiter, positioned in Martian orbit, had finally captured 3I Atlas, the third confirmed interstellar object to pass through our solar system. The image appeared on official channels at 14:47 UTC. What the world saw was a small, fuzzy white dot against the blackness of space. It looked, to put it bluntly, like someone had sneezed on the camera lens. No detail, no structure. Just a smudge of light that could have been anything from a distant comet to a stuck pixel. The resolution told part of the story. The ExoMars Trace gas orbiter captured the image at 1136 microradians per pixel. At the distance 3I Atlas occupied that day, approximately 30 million kilometers from Mars, each pixel represented roughly 340 kilometers of space. Imagine trying to identify our car from orbit, except the car is the size of a city, and you're viewing it from another planet. The image revealed nothing about shape, nothing about surface features, nothing about the anomalies that had sparked months of speculation. Social media erupted in disappointment. Forums that had buzzed with theories about artificial origins, about probes from distant civilizations, about technology beyond human comprehension, fell silent. The image seemed to confirm what skeptics had argued all along. Just another comet, just another lump of ice and rock drifting through the void. But disappointment, in science, can be premature. Within hours of the official release, something strange began happening. Amateur astronomers, the kind of people who spend cold nights in backyard observatories tracking objects NASA considers routine, started comparing notes. They had been watching 3I Atlas for weeks, using their own equipment, their own techniques, and what they were seeing didn't match the ESA image. One astronomer in Chile, using a 14-inch Schmidt-Cassegrain telescope, had captured images on October 7th showing what appeared to be a structured shape, something with edges, with geometry. Another observer in Australia reported similar findings on October 8th. Both images showed far more detail than the official ESA release, despite being taken with equipment vastly inferior to an orbital space probe. The discrepancy raised an uncomfortable question. If backyard telescopes could capture more detail than one of humanity's most advanced orbital observatories, what exactly had gone wrong with the ExoMars image? Was it a technical failure, a processing error, or something else entirely? The ESA offered no immediate explanation. Press releases remained generic, technical, carefully worded. The image was described as preliminary, as part of ongoing observation campaigns, as one data point among many. But the silence on the quality issue was notable. No apology for the blurry result. No promise of better images to come. Just the image itself, hanging in digital space like an unanswered question. 3I Atlas had been discovered 6 months earlier, in April 2025, by the Atlas Survey System in Hawaii. The designation 3I marked it as the third interstellar visitor, following 1I Oumuamua in 2017 and 2I Borisov in 2019. Unlike those predecessors, 3I Atlas arrived with controversy already attached. Its trajectory showed a nearly perfect ecliptic alignment, a 4.89-degree inclination that seemed too precise to be random. Its velocity, its path through the inner solar system, its timing, all carried hints of something deliberate. Avi Loeb, the Harvard astrophysicist who had argued for years that Oumuamua might be artificial, immediately focused on 3I Atlas. If Oumuamua had been controversial, 3I Atlas was a provocation. The numbers didn't lie, Loeb argued in papers and interviews. Natural objects don't follow such precise paths. Natural objects don't time their arrivals with such accuracy. The scientific community predictably pushed back. Comets can have unusual orbits, gravitational interactions with distant stars, with rogue planets, with the galaxy itself can nudge objects into unlikely trajectories. The fact that something seems improbable doesn't make it impossible. Science deals in evidence, not intuition. But the blurry ESA image had changed something. It hadn't answered questions. It had created new ones. And in the silence that followed its release, in the gap between what amateur astronomers were seeing and what official channels were showing, a different kind of investigation was beginning. Because sometimes the most important data isn't what agencies choose to release. Sometimes it's what they choose to withhold. And sometimes a blurry image tells you more by what it hides than by what it shows. The Mars Reconnaissance Orbiter, another spacecraft with a view of 3I Atlas, had yet to release any images at all. NASA's Perseverance rover, equipped with high-resolution navigation cameras capable of imaging distant objects, remained silent. The James Webb Space Telescope, the most powerful observatory ever built, had not published a single observation of 3I Atlas despite its capabilities. The official explanation was scheduling conflicts, technical limitations, priority targets. But the timing felt wrong. 3 space agencies, multiple observatories, all with clear views of the most intriguing interstellar visitor in human history, and the only public image was a fuzzy dot that revealed nothing. In forums and chat rooms, people began asking a simpler question: not whether 3I Atlas was artificial, not whether governments were hiding evidence. Just this: why would you spend billions building the most advanced cameras humanity has ever created, point them at the most important astronomical event in a generation, and then release an image that shows less than a backyard telescope? The answer: whatever. It wasn't in the official channels. It was somewhere in the gap between what technology could see and what the public was being shown. And as October wore on, as 3I Atlas moved closer to its perihelion passage behind the Sun, that gap was about to get a lot wider. On October 12th, 2 days after the disappointing ESA release, an image appeared on an amateur astronomy forum that changed everything. It wasn't from an official source. It wasn't from a government agency. It came from a user, with the handle Skywatcher AU, claiming to be an amateur astronomer in Western Australia. The image showed 3I Atlas from October 9th, captured using what the poster described as a 16-inch Ritchie-Chrétien telescope with adaptive optics. The level of detail was stunning. Where the ESA image had shown a fuzzy blob, this showed structure. The object appeared elongated, roughly cylindrical, with what looked like surface variations, areas of different reflectivity. The aspect ratio was immediately striking. The object measured approximately 400 meters in length and perhaps 40 meters in width, a 10-to-1 ratio that didn't match any known comet profile. Natural comets tend toward irregular, potato-like shapes, the result of accretion and collision over billions of years. This looked manufactured, like something designed rather than formed. Forum members immediately began dissecting the image. Some called it a hoax, a digital creation designed to fuel conspiracy theories. Others defended its authenticity, pointing to metadata, to atmospheric distortion patterns consistent with ground-based observation, to the technical difficulty of faking such an image convincingly. Within 6 hours, the thread had accumulated over 10,000 responses. Within 12 hours, the original poster had vanished. The account went dark. The image remained, copied and shared across platforms, but Skywatcher AU never returned to answer questions or provide additional data. The timing of the disappearance raised immediate suspicions. Had the poster been contacted by authorities? Had they received legal threats? Or had they simply realized the attention was more than they wanted? The internet, predictably, assumed the worst: silencing, suppression, cover-up. But the image itself demanded attention regardless of its origin. If it was real, it represented clear evidence of an anomalous object. If it was fake, it was a remarkably sophisticated fake, and the question became, why? Someone would invest such effort into creating it. Professional astronomers began attempting verification. Multiple observatories pointed instruments at 3I Atlas, trying to replicate the amateur's result. The problem was distance and timing. By October 12th, 3I Atlas had moved closer to the Sun, making ground-based observation increasingly difficult. Solar glare, atmospheric interference, and the object's changing position limited what could be captured from Earth. One astronomer in New Mexico managed partial confirmation. Using a 20-inch telescope and stacking multiple exposures, they captured an image showing elongation, though not with the clarity of the Australian leak. The aspect ratio appeared similar, the general shape consistent, but details remained fuzzy. The partial confirmation was enough to shift the conversation. The question stopped being whether the leaked image was authentic and became why official sources weren't providing similar clarity. If amateurs could capture structural details, why couldn't the ExoMars orbiter? Why hadn't Mars Reconnaissance Orbiter released anything? Why the silence from Perseverance? Then came the second anomaly. A graduate student in astrophysics, analyzing the leaked image using photometric software, noticed something odd about the reflectivity patterns. The object wasn't reflecting light uniformly. Certain sections appeared darker, almost absorptive, while others showed high albedo, reflecting sunlight intensely. The pattern didn't match known cometary behavior. Comets reflect light based on surface composition, typically ice, dust, and organic compounds. The reflectivity is relatively uniform, with variations caused by outgassing or surface irregularities. But this showed distinct zones, almost as if different materials were present in different sections. The student published their analysis on arxiv.org, the preprint server used by physicists and astronomers. The paper was cautious, avoiding explicit claims of artificiality, but the implications were clear. The reflectivity pattern suggested either an extremely unusual natural object or something with designed surface properties. Professional journals showed no interest in publishing the paper. Peer reviewers cited lack of verification, questionable source material, insufficient data. The paper remained in preprint limbo, cited in forums and alternative media, but ignored by mainstream science. The pattern was emerging. Amateur data showing anomalies. Official sources remaining silent. Professional institutions declining to engage. Each response, or lack thereof, feeding a narrative of concealment. By October 15th, pressure was building on space agencies to release better imagery. Social media campaigns demanded transparency. Hashtags trended. Petitions circulated. The ESA issued a brief statement acknowledging public interest and promising additional observations, but provided no timeline, no specifics, no commitment. NASA remained entirely silent. No press releases, no acknowledgement of the controversy. The Perseverance team continued publishing routine images of Martian geology, of soil samples, of atmospheric measurements, but nothing regarding 3I Atlas, despite the rover's capability to image distant objects. The silence spoke volumes. In an era of constant communication, of instant updates, of agencies competing for public attention and funding, complete silence on the most discussed astronomical object in years felt deliberate. It felt like policy. And then someone leaked something far more interesting than an image. On October 17th, an anonymous user on a different forum posted what they claimed was internal communication from NASA's Jet Propulsion Laboratory. The message, dated October 11th, referenced 3I Atlas and included a single line that would dominate discussion for days. All public-facing observation requests for Object 3I denied pending review. Classification level TBD. If authentic, the message suggested active suppression, not technical limitations, not scheduling conflicts, deliberate withholding of data pending classification review. Classification implied security concerns, implied something beyond routine science, implied that what agencies were seeing wasn't meant for public consumption. Verification proved impossible. The leak included no identifying information, no names, no specific enough details to confirm or deny authenticity. It could have been fabricated by anyone with basic knowledge of NASA's internal communication style, but it could also have been real, a whistleblower risking career and legal consequences to signal that something was being hidden. The response from official channels was, once again, silence. No denial, no confirmation, just the void where answers should have been. As October progressed toward perihelion, scheduled for October 29th, the information landscape had fractured into two incompatible realities. In one, 3I Atlas was a routine interstellar comet receiving appropriate scientific attention, with data released according to standard protocols. In the other, it was an anomalous object, possibly artificial, being actively concealed by multiple space agencies for reasons unknown. The amateur leak had done what the official image couldn't. It had created doubt. It had suggested that what the public was being shown bore no resemblance to what instruments were actually seeing. And in the gap between those two realities, speculation was growing into something harder to contain. Because once people suspect they're not being told the truth, once that seed of doubt takes root, every silence becomes suspicious. Every delay becomes evidence. Every bland reassurance becomes proof of the opposite. And the silence, as 3I Atlas moved closer to the sun, was growing deafening. Spectrography offers a way to read the chemical composition of objects across vast distances. When light from the sun reflects off a comet, passes through its coma, or emerges from outgassing, that light carries fingerprints. Every element absorbs and emits specific wavelengths, creating a barcode that astronomers can decode. It's a technique so fundamental, so reliable, that it forms the backbone of modern astronomy. On October 18th, the first spectroscopic analysis of 3I Atlas reached the public domain, not through official channels, not through peer-reviewed journals, but through an astronomer in South Africa who posted raw data to a personal blog. The results were immediately controversial. The spectrum showed nickel, clear, unmistakable spectral lines corresponding to neutral nickel atoms appearing at wavelengths around 341.5 nanometers and 352.5 nanometers. The presence of nickel in cometary spectra isn't impossible. Comets formed from the same primordial material as planets, and nickel exists throughout the solar system. But nickel without corresponding ion signatures is deeply unusual. Iron and nickel are twins in cosmic chemistry. They form together in stellar cores, disperse together in supernovae, condense together in planetary accretion. Finding one without the other is like finding left shoes scattered across a landscape with no right shoes anywhere. It can happen, but it demands explanation. The South African astronomer Dr. Willem Krause included a note with the data. The observation had been taken on October 14th using the Southern African Large Telescope, one of the largest single optical telescopes in the world. The exposure time was 90 minutes, long enough to capture faint spectral features. The data reduction was standard, using software packages verified across thousands of previous observations. The nickel lines were strong, not faint traces requiring careful analysis to detect. Strong, clear signals that any competent spectroscopist would identify immediately. And the iron lines, where they should have appeared around 358.1 nanometers and 372.0 nanometers, were absent. Within the astronomy community, responses divided sharply. Some argued the observation was flawed, perhaps contaminated by instrumental artifacts or misidentified spectral features from Earth's atmosphere. Others suggested unusual cometary composition, perhaps the result of the object's interstellar origin and exotic formation conditions. A smaller group whispered about deliberate chemical manufacturing, about alloy selection for specific purposes, about designs rather than accidents. Dr. Krause attempted to publish the findings in mainstream journals. All declined review. The reasons varied, formal rejections citing insufficient verification, but the pattern was consistent. Nobody wanted to touch data suggesting 3I Atlas wasn't a normal comet, especially data coming from outside major institutional channels. The rejection wasn't surprising. Academic publishing operates on consensus, on verification, on reputation. A single observation of anomalous chemistry, no matter how technically sound, doesn't override established understanding. But the refusal to even review the data struck many as excessive caution, bordering on deliberate avoidance. Then came the thermal contradiction. On October 20th, infrared observations from a private observatory in Chile detected something impossible. The object was showing thermal signatures inconsistent with solar heating. Comets heat up as they approach the sun. It's basic physics. Solar radiation strikes the surface, warming ice, causing outgassing, creating the characteristic tail. The thermal signature should match distance from the sun, surface composition, and rotation rate. It's predictable, calculable, well understood. 3I Atlas was colder than it should have been. At its distance from the sun on October 20th, roughly 0.4 astronomical units, about 60 million kilometers, the expected surface temperature should have been around 250 Kelvin, well above the sublimation point of water ice. Instead, infrared measurements indicated temperatures closer to 180 Kelvin, cold enough that outgassing should have been minimal or absent. Yet 3I Atlas was showing a faint coma, the hazy envelope of gas and dust that surrounds active comets. The coma existed without sufficient heat to produce it. It was like watching someone sweat in a freezer, a violation of basic thermodynamics. The Chilean observatory published their data with a note of bewilderment. They'd triple-checked calibrations, verified the observation against known objects, eliminated instrumental error. The measurements were solid. The physics made no sense. Possible explanations emerged in theoretical papers and forum discussions. Perhaps the object had unusual thermal conductivity, interior heat retained from formation or from radioactive decay. Perhaps the coma wasn't water ice, but some more volatile compound, sublimating at lower temperatures. Perhaps the infrared readings were being affected by surface properties that absorbed and re-emitted thermal radiation in unexpected ways. Each explanation worked in isolation, but failed when combined with the other anomalies. Unusual thermal conductivity didn't explain the nickel without iron spectrum. Exotic volatile compounds didn't match observed outgassing patterns. Surface properties that could manipulate thermal emission suggested materials science beyond natural processes. By late October, 3I Atlas had accumulated a profile that defied natural explanation without requiring multiple, unlikely coincidences. The trajectory was too precise. The shape was too regular. The chemistry was impossible. The thermal behavior broke thermodynamic expectations. Any one anomaly could be dismissed. Altogether, they formed something harder to ignore. Yet official channels remained committed to the natural comet hypothesis. NASA, ESA, and other agencies continued describing 3I Atlas as an interstellar visitor, interesting but not extraordinary. Press releases used careful language, acknowledging unusual features, but framing them as opportunities for scientific study rather than fundamental challenges to understanding. The disconnect between official narrative and accumulating evidence was creating cognitive dissonance. Either multiple independent observations were flawed, or institutions with access to far better data were misrepresenting what they were seeing. Neither option was comfortable. In academic circles, private conversations were occurring that never made it into public statements. Researchers who had seen preliminary data from major observatories spoke carefully, avoiding specifics, but hinting at complexity beyond what had been released. The message was consistent. Official sources knew more than they were sharing, and what they knew was more troubling than the public narrative suggested. Avi Loeb published an opinion piece arguing that the accumulation of anomalies demanded extraordinary consideration. If 3I Atlas were an artificial object, a probe, from another civilization, what would we expect to see? Precise trajectory, structured geometry, unusual material composition, thermal management systems. Every criterion was being met, yet institutions remained committed to conventional explanations. The response to Loeb's piece was swift and harsh. Fellow astronomers published rebuttals, accusing him of sensationalism, of abandoning scientific rigor, of feeding conspiracy theories. The tone of the criticism suggested something beyond professional disagreement. It felt like enforcement, like boundary maintenance, like a warning to anyone else considering similar arguments. But the warnings came too late. The spectroscopic ghost, the thermal contradiction, the chemical impossibilities had already escaped institutional control. Amateur astronomers had the data, independent researchers had the numbers, and millions of people watching from the sidelines had a simple question that no amount of professional gatekeeping could suppress. If this is just a comet, why doesn't it behave like one? The answer, whatever it was, wouldn't come from press releases or peer-reviewed journals. It would come from direct observation, from the convergence of instruments on perihelion, from the moment when 3I Atlas passed closest to the Sun and emerged on the other side. If it emerged at all. On October 22nd, something extraordinary appeared on 4chan's Index board, the corner of the internet dedicated to paranormal phenomena and conspiracy theories. Among the usual noise of alien abduction stories and blurry UFO photos, someone posted what they claimed was spectroscopic data from 3I Atlas showing a radio frequency emission at 14 to 20 455,556 megahertz. The number itself stopped anyone with astronomy knowledge in their tracks. 1420 45556 megahertz is the hydrogen line, the frequency at which neutral hydrogen atoms emit radiation. It's one of the most important frequencies in radio astronomy, used to map the galaxy, to track star formation, to measure cosmic expansion. It's also famously the frequency of the wow signal. On August 15, 1977, Jerry Amon was reviewing printouts from the Big Ear radio telescope at Ohio State University when he saw something that made him grab a red pen and write "wow" in the margin. For 72 seconds, the telescope had detected a narrow-band radio signal at 1420 by 45556 MHz, far stronger than background noise, originating from somewhere near the constellation Sagittarius. The signal never repeated. Decades of follow-up observations found nothing. Explanations ranged from terrestrial interference to passing satellites to natural astronomical phenomena. But the signal remained officially unexplained, a footnote in SETI history, a tantalizing hint of something that might have been communication or might have been noise. The 4chan post claimed that 3I Atlas was emitting at precisely the same frequency, not approximately, not within measurement error. Exactly 1420.45556 Nords, the hydrogen line, the universal beacon, the frequency any technological civilization would recognize. The post included what appeared to be spectrogram data, showing a sharp spike at the claimed frequency. The image quality was poor, clearly a photo of a computer screen rather than a direct data export. No source was identified, no observatory was named. The poster's username was a random string of characters, and they never responded to requests for verification. Immediate dismissal seemed warranted. 4chan has earned its reputation as an unreliable source, a platform where hoaxes and genuine information coexist in indistinguishable chaos. Posting sensitive data there would be professional suicide for any legitimate researcher. Yet the post persisted, copied and analyzed, because the claimed frequency was too specific to be random fabrication. Amateur radio astronomers began attempting verification. The problem was technical and practical. Detecting a faint radio signal from an object millions of kilometers away requires large antenna arrays, sophisticated receivers, and careful filtering of terrestrial interference. The equipment isn't available to most amateurs, and those with access operate through institutional channels that had shown little interest in supporting verification of controversial claims. Still, attempts were made. A group in the Netherlands, using a small radio telescope array, attempted observation on October 23rd. They reported detecting something at approximately 1420 MHz, but the signal was weak, intermittent, and potentially contaminated by satellite transmissions. The observation was inconclusive, neither confirming nor denying the 4chan claim. What made the post significant wasn't the spectrogram itself, but what it implied if true. Natural objects don't emit coherent radio signals at specific frequencies. Pulsars emit across broad spectra. Quasars produce radiation through accretion processes. Even if 3I Atlas contained hydrogen, which was expected, natural emission would be diffuse, weak, and spread across frequencies. A narrow-band emission at exactly 1420.44556 MHz suggested either deliberate transmission or an extraordinary coincidence. And if transmission, it suggested something trying to be noticed, something using a frequency that any civilization with radio astronomy would immediately recognize. The connection to the WOW signal added another layer of interpretation. If 3i Atlas had sent the 1977 signal, it would have been approximately 48 light-years away at the time, moving through interstellar space on its long journey toward our solar system. The timing worked mathematically. An object traveling at 3i Atlas's velocity could have covered that distance in the intervening years. But why send a signal 48 years before arrival? The most logical answer, if this speculation had any validity, was announcement. A probe entering an inhabited star system might want to signal its presence long before. Getting close, giving the native civilization time to notice, to prepare, to avoid misunderstanding. A beacon saying, "We're coming, we're artificial, please don't shoot." The speculation required accepting multiple unverified premises: that the 4chan post was real, that 3i Atlas was emitting at 1420 MHz, that the emission was artificial, that it connected to the WOW signal, that the whole scenario implied intentional communication. Each step multiplied improbability, yet the alternative, explanations seemed equally strained. If the post was a hoax, it was a remarkably informed hoax, requiring knowledge of radio astronomy, of SETI history, of the specific parameters of 3i Atlas's trajectory. If coincidence, it was coincidence piled upon coincidence, too many unlikely elements aligning by chance. Professional astronomers who privately accessed major radio telescope data weren't talking publicly, but their silence felt different from earlier silence. It felt less like dismissal and more like caution, like people who had seen something troubling and didn't know how to discuss it without career consequences. By October 24th, the 4chan signal had become part of the broader narrative around 3i Atlas. Believers cited it as confirmation of artificial origin. Skeptics dismissed it as obvious fabrication. And in the middle, a growing number of people simply wanted verification, wanted someone with proper equipment to point a radio telescope at 3i Atlas and definitively settle whether anything was broadcasting at 1420 MHz. That verification never came. Every major radio observatory claimed scheduling conflicts, technical limitations, or insufficient justification for the observation. The explanations were plausible individually, but suspicious collectively. SETI researchers who spent careers scanning the sky for artificial signals showed no public interest in checking whether an actual interstellar object might be broadcasting. The pattern of avoidance had become too consistent to explain through mundane reasons. It looked like coordination, like a decision made at institutional levels to avoid collecting data that might force uncomfortable conclusions. And if institutions were avoiding that data, it raised the question of what they'd already found. Because observatories don't ignore potentially revolutionary discoveries without reason. They don't pass up opportunities for fame and funding and Nobel Prizes unless something has already been discovered that makes public observation undesirable. The 4chan signal remained unverified, but also unrefuted. It hung in informational limbo, like so much else about 3i Atlas, neither confirmed nor denied, neither released nor suppressed, existing in the gap between what was known and what was being acknowledged. As perihelion approached, that gap was becoming a chasm, and the question was no longer whether 3i Atlas was hiding secrets. The question was whether anyone in authority would admit to knowing what those secrets were. Numbers don't lie, but they can whisper uncomfortable truths. On October 25th, a statistical analysis appeared on arxiv.org that would fundamentally shift how seriously people took the 3i Atlas anomalies. The paper was authored by a team at MIT, mathematicians rather than astronomers, approaching the question with pure probability theory rather than astrophysical assumptions. The question they asked was simple. What are the odds that 3i Atlas's trajectory is natural? Interstellar space is vast beyond human comprehension. A single cubic light-year contains essentially nothing, just scattered atoms and molecules, so diffuse that laboratory vacuums are dense by comparison. Objects moving through this void, follow paths determined by gravity, by initial velocity, by the cumulative pull of every massive body in the galaxy. When an interstellar object enters our solar system, its trajectory is essentially random from our perspective. It can come from any direction, at any angle, with any velocity within plausible ranges. The ecliptic plane, the flat disk where planets orbit the Sun, is just one possible orientation among infinite possibilities. 3I Atlas entered the solar system with a 4.89-degree inclination to the ecliptic. That's not perfectly aligned, but it's remarkably close. The ecliptic itself spans 360 degrees of possible approach angles. An object approaching randomly has equal probability of coming from any angle, like throwing a dart at a globe, while blindfolded. The MIT paper calculated that probability. An interstellar object entering the solar system has approximately a 1 in 36 chance of approaching within 10 degrees of the ecliptic plane. 3I Atlas came in at less than 5 degrees. Narrowing the angle to within 5 degrees reduces probability to approximately 1 in 72. Unlikely, but not impossible. 1 in 72 odds occur regularly, but that was just the beginning of the calculation. The paper then considered velocity. Interstellar objects have speeds determined by their ejection from origin stellar systems and by gravitational acceleration during their journey. The distribution of possible velocities follows known patterns based on galactic dynamics. Most interstellar objects travel between 10 to 30 kilometers per second relative to the Sun. 3I Atlas was traveling at 26.3 kilometers per second. Well within the expected range, nothing anomalous about the number itself. But the direction of that velocity, the vector, was aligned almost perfectly with the ecliptic plane, not just approaching at a shallow angle, but moving parallel to the plane where planets orbit. The probability of both angle and velocity vector aligning so closely was calculated at approximately 1 in 5,000. Still possible, still within the range where natural explanation remains viable. But the calculation wasn't finished. The paper considered timing. 3I Atlas didn't just pass through the solar system. It arrived with trajectory and velocity that brought it close to Earth and Mars during a period when multiple space observatories were operational and positioned to observe it. The probability of an interstellar object passing close enough to inner planets for detailed observation, during a window when humanity has the technology to notice and study it, was conservatively estimated at 1 in 10,000 for any given interstellar visitor. Multiplying the probabilities together, accounting for the specific combination of trajectory, angle, velocity alignment, and observation timing, the paper calculated odds of approximately 1 in 50 million that a random interstellar object would present exactly the profile that 3I Atlas presented. 1 in 50 million. Those are lottery-winning odds. They're odds that make you check your ticket 3 times because surely there's been a mistake. But the paper didn't stop there. It went further, into territory that pushed beyond probability and toward implication. If 3I Atlas were artificial, if it were a designed object with a purpose, what trajectory would it follow? The answer was obvious. It would approach along the ecliptic, where targets of interest, planets, are located. It would maintain velocity that allowed extended observation without excessive speed. It would time its arrival to maximize the chance that any technological civilization would notice. In other words, 3I Atlas was following exactly the trajectory that a probe would follow if designed to be noticed, and studied by inhabitants of this solar system. The MIT paper was careful not to explicitly claim artificial origin. Academic papers don't make such claims without overwhelming evidence, and statistical improbability alone doesn't constitute proof. But the numbers were there, published, peer-reviewed by mathematicians who verified the calculations were sound. Response from the astronomical community was swift and divided. Some researchers embraced the analysis, arguing it provided quantitative support for what qualitative observations had been suggesting. Others rejected it, claiming the paper cherry-picked parameters, that calculating odds after observing an event is meaningless, that any specific trajectory would be equally improbable if analyzed in sufficient detail. The methodological criticism had merit. In probability theory, calculating the odds of something after it's already happened is vulnerable to selection bias. You can make any event seem improbable by choosing your parameters carefully enough, but the MIT paper had used standard astronomical parameters, widely accepted values for galactic velocity distributions and orbital mechanics. More troubling to critics was what the paper implied about institutional response. If major observatories had access to trajectory data, if they'd run similar calculations, they would have arrived at similar conclusions. The statistical improbability of 3I Atlas's path would have been apparent from the moment precise orbital parameters were calculated. Yet no institutional source had published such an analysis. No major observatory had released papers discussing the statistical significance of the trajectory. The silence suggested either that calculations hadn't been done, which seemed professionally negligent, or that they'd been done and results were being withheld. The MIT paper forced a conversation that institutions had been avoiding. If the trajectory was statistically significant, it demanded explanation. Natural processes remained possible. Extraordinary coincidences occur, but the burden of proof had shifted. Dismissing artificial origin now required explaining how something with 1 in 50 million odds had occurred naturally while appearing exactly as a designed object would appear. By October 26th, mainstream media had begun covering the statistical analysis. Articles appeared in major publications, carefully hedged with qualifications and expert skepticism, but covering the story nonetheless. The narrative had escaped academic gatekeeping and entered public consciousness. Social media erupted with debate. Hashtags trended globally. Video explainers accumulated millions of views. The question of whether humanity was being visited by an artificial object from another civilization had moved from fringe speculation to mainstream discussion, and through it all, official sources maintained their position. 3I Atlas was an interstellar comet, interesting and worthy of study, but ultimately natural. The trajectory was unusual but not impossible. The chemistry was unexpected but not inexplicable. The thermal behavior was puzzling but would be understood with better data. The statistical nightmare had become a problem of narrative authority. Either millions of people were misunderstanding probability and seeing patterns in randomness, or institutions with access to the best data and analysis were lying about what they knew. 3 days remained until perihelion. 3 days until 3I Atlas passed behind the Sun, temporarily disappearing from observation. 3 days for someone in authority to acknowledge that maybe, just maybe, the numbers were telling a story that demanded more than dismissal. But acknowledgement requires courage, and institutions built on certainty struggle when confronted with fundamental uncertainty. So the silence continued, even as the statistical nightmare made that silence increasingly difficult to justify. And those who were paying attention began to realize that the real question wasn't about 3I Atlas's origin. It was about what happens when truth becomes inconvenient, when discovery challenges stability, when knowledge threatens the illusion of control. Because if institutions were suppressing evidence of an artificial interstellar object, what else might they suppress? What other truths might be withheld because the cost of revealing them seemed too high? The statistical nightmare wasn't just about odds and trajectories. It was about trust, about transparency, about whether the structures humanity had built to understand the universe could handle truths they weren't designed to accommodate. By October 27th, a pattern had emerged that was harder to explain than any individual anomaly. Multiple space agencies, operating independently across different continents with different funding structures and political oversight, were all responding to 3I Atlas in essentially identical ways. The coordination wasn't explicit. No, joint statements had been issued. But the parallel behavior suggested communication happening beyond public view. The European Space Agency had released one blurry image and nothing since. NASA had released nothing at all. The Russian space agency Roscosmos, which typically published data independently of Western agencies, had made no public observations. The China National Space Administration, increasingly active in space science, and often eager to demonstrate capabilities exceeding Western. Institutions had remained entirely silent. Japan's JAXA, India's ISRO, even private companies like SpaceX with observational capabilities, all quiet. The silence spanned national boundaries, political rivalries, commercial competition. It was as if someone had sent a memo to every entity with space observation capability, and that memo said, "Do not publish data about 3I Atlas." The coordination became undeniable when researchers began attempting to access observatories through normal, professional channels. Astronomers request telescope time through formal processes, submitting proposals that are peer-reviewed and scheduled months in advance. Priority is typically given to novel observations, to potentially significant discoveries, to anything that might advance understanding. Multiple researchers attempted to schedule observations of 3I Atlas through this process. A team in Canada submitted a proposal to use the Canada-France-Hawaii telescope for spectroscopic follow-up. A group in Germany requested time on the Very Large Telescope in Chile for high-resolution imaging. An American team applied for James Webb Space Telescope observations to capture infrared data during perihelion passage. All requests were denied. The rejections used different language, cited different technical reasons, but the pattern was absolute. No major observatory was accepting proposals for 3I Atlas observation. The object that should have been the highest priority target in astronomy was being systematically excluded from observational schedules. One astronomer, speaking anonymously to a science journalist, described it as unprecedented coordination of avoidance. In their 20-year career, they'd never seen an interesting object generate such uniform institutional disinterest. The natural response to something anomalous is intense scrutiny, competition among institutions to publish first, to claim discovery, to advance knowledge. Instead, the response was coordinated withdrawal. The question became who had the authority to coordinate such withdrawal. Space agencies operate under governmental oversight, but they maintain scientific independence. NASA scientists don't typically take orders from White House staff about what to observe. ESA researchers answer to scientific committees, not political appointees, yet something was enforcing silence across institutions that normally competed fiercely. The mechanism wasn't visible in public communications, but the effect was unmistakable. Some speculated about national security concerns. If 3I Atlas were artificial, if it represented technology from another civilization, perhaps governments had classified the information under existing frameworks for protecting sensitive data. But classification typically affects military and intelligence agencies, not civilian space programs, and classification doesn't explain coordination across nations with competing security interests. Others pointed to international agreements. Protocols exist for handling potential contact with extraterrestrial intelligence, frameworks developed by organizations like the International Academy of Astronautics. These protocols emphasize careful verification and coordinated announcement. Perhaps 3I Atlas had triggered these protocols, explaining the institutional silence as responsible caution rather than suppression. But protocols designed for radio signals for potential SETI detection don't obviously apply to physical objects passing through the solar system. And even if they did, the protocols called for transparency after verification, not indefinite silence. By October 27th, the silence had generated its own crisis. In the absence of official information, speculation had metastasized into certainty for many observers. Online communities had concluded that 3I Atlas was definitely artificial, that governments definitely knew, that suppression was definitely occurring. The lack of denial was taken as confirmation. This created a trap for institutions. Denying the artificial origin hypothesis now would appear defensive, would invite accusations of gaslighting, would fuel conspiracy theories. But continuing silence allowed those theories to spread unchallenged, potentially causing greater damage to institutional credibility. A few researchers attempted to break the silence independently. On October 27th, an astronomer in Spain held a press conference announcing plans to conduct independent observations during perihelion using a privately funded telescope. The event was scheduled for 15:00 local time. At 14:30, the astronomer cancelled, citing unforeseen personal circumstances. They provided no additional details and declined all interview requests. The cancellation, occurring 30 minutes before the scheduled press conference, suggested intervention. Someone had contacted the astronomer, conveyed information or threats or consequences sufficient to halt the announcement. The timing was too precise to be coincidental. Similar patterns occurred elsewhere. A graduate student who had been vocal on social media about anomalies deleted their account. A blogger who had been aggregating amateur observations suddenly ceased posting. A podcast that had dedicated several episodes to 3i Atlas released a brief statement saying they would no longer cover the topic. Each individual silence could be explained through personal choice, through deciding the controversy wasn't worth professional risk. But collectively, the patterns suggested pressure being applied systematically to anyone attempting to maintain public discussion. The pressure wasn't leaving visible traces. No legal actions were filed. No official warnings were issued. Whatever was happening occurred through channels that left no public record. Conversations in private, implications about career consequences, suggestions that continuing certain lines of discussion would be professionally unwise. This kind of soft suppression is more effective than overt censorship. It doesn't create martyrs or attract attention to what's being suppressed. It simply makes people choose silence voluntarily, deciding that speaking up isn't worth the personal cost. By late October 27th, public discussion of 3i Atlas had fractured into two isolated domains. Mainstream media had largely moved on, treating the story as a curiosity that had fizzled, interesting for a news cycle, but lacking substance for sustained coverage. Alternative media and online communities continued intense discussion, but increasingly within echo chambers, talking to themselves rather than reaching broader audiences. The fracturing served to contain the controversy. People who believed something extraordinary was occurring could discuss it among themselves without influencing wider public opinion. People who dismissed the anomalies as misinterpretation or hoax could ignore the continued discussion as fringe speculation. Institutions had successfully created informational quarantine without overt censorship. The story hadn't been killed, it had been marginalized, pushed to spaces where it wouldn't threaten mainstream narratives or force institutional responses. But quarantine only works if nothing breaks containment. And perihelion, now less than 48 hours away, represented a moment when containment might fail. When 3i Atlas passed behind the sun and emerged on the other side, amateur observers would be watching. Private. Telescopes would be pointed skyward. If something extraordinary happened, if the object behaved in ways that couldn't be dismissed, the coordinated silence would collapse under the weight of observable reality. The institutions maintaining silence knew this. They had to know that perihelion was a risk point, a moment when their ability to control narrative would be tested, which raised the question of what they expected to happen. If 3i Atlas were just a comet, perihelion would be routine. The object would heat up, outgas more intensely, perhaps fragment if thermal stress exceeded structural integrity. Standard cometary behavior, nothing that would challenge the natural origin hypothesis. But if institutions expected routine behavior, why the extraordinary effort to suppress observation? Why deny telescope time? Why pressure researchers into silence? Why coordinate across agencies and nations to prevent data collection? The only logical answer was that institutions expected something non-routine. They expected perihelion to reveal something that would be difficult to explain through natural processes, and they preferred that revelation to occur without detailed observational data, without professional astronomers on record documenting what happened. Flying blind into the most important observational moment meant accepting that whatever occurred would be poorly documented, easily dismissed, impossible to verify. It meant allowing ambiguity to persist, preventing definitive conclusions that might force institutional acknowledgement. The coordinated silence, viewed through this lens, wasn't about suppressing current knowledge. It was about preventing future knowledge, about ensuring that when 3i Atlas did whatever it was going to do, nobody with credibility would be watching closely enough to prove anything. That kind of strategic silence suggested institutional certainty about what was coming. It suggested that somewhere, in secure facilities with classified data, people knew what 3i Atlas would do at perihelion, and they had decided that the public was better off not knowing. As October 27th ended and October 28th began, the world moved toward perihelion, largely unaware that anything significant was about to occur. Mainstream media had moved on. Public attention had shifted to other stories. Only those still paying attention, still tracking the silence and the suppression and the statistical improbabilities, understood that the next 48 hours might answer questions humanity hadn't been ready to ask, or that they might answer nothing at all, leaving only deeper silence, more sophisticated suppression, and the growing realization that some truths are deemed too dangerous to acknowledge. Mars, in late October 2025, occupied an almost perfect position for observing 3i Atlas. The planet sat approximately 90 million kilometers from the object's perihelion point, with viewing geometry that provided unobstructed observation during the critical passage. Multiple spacecraft orbiting Mars carried instruments capable of capturing detailed imagery and spectroscopic data. It was, from an observational standpoint, an ideal scenario. The Mars Reconnaissance Orbiter had been circling the planet since 2006, equipped with HiRISE, the High-Resolution Imaging Science Experiment. HiRISE can resolve features as small as 30 centimeters on the Martian surface from orbital altitude. Pointed into space at 3i Atlas's distance, each pixel represented approximately 30 kilometers. At that resolution, an object 400 meters long would span roughly 13 pixels, enough to discern shape, rotation, and surface features. The ExoMars Trace gas orbiter carried similar capabilities. Its CASIS imaging system, designed for mapping Martian geology, could be repurposed for astronomical targets. The European Space Agency had already released one image from this instrument, the blurry disappointment from October 10th. But the orbiter remained operational, perfectly positioned, capable of far better results. NASA's Perseverance rover, though grounded on the Martian surface, carried navigation cameras capable of imaging distant objects. The NavCam system used 0.33 milliradian resolution, which at 3i Atlas's distance of approximately 38 million kilometers during perihelion would yield roughly 12 kilometers per pixel. Not as detailed as orbital assets, but sufficient to capture structural features and monitor behavior during the critical passage. All three platforms had clear lines of sight. All three were operational. All three were controlled by agencies claiming scientific interest in 3i Atlas. Yet as perihelion approached, none published observational plans. No press releases announced special observation campaigns. No papers appeared describing data collection strategies. The perfect observational window was being ignored. The silence from Mars-based assets was particularly troubling because these platforms were already positioned, already operational, already pointing instruments towards space regularly for calibration and testing. Using them required no special maneuvering, no fuel expenditure, no risk to primary missions. It was essentially free observation of potentially the most significant object to pass through the inner solar system in recorded history. On October 28th, less than 36 hours before perihelion, a flight engineer who had worked on Mars Reconnaissance Orbiter published an anonymous post on an engineering forum. The post claimed that HiRISE had been commanded to observe 3i Atlas on October 15th, capturing a series of high-resolution images. According to the engineer, the images showed clear structural details, including what appeared to be surface patterns inconsistent with natural formation. The post continued, claiming that these images had been classified immediately upon downlink to Earth, transferred to secure servers, and removed from standard mission data archives. The engineer expressed frustration that scientifically significant data was being withheld from researchers who could analyze it properly. Verification was impossible. The post was anonymous, provided no proof, could have been fabricated by anyone familiar with MRO operations. But the technical details were accurate, the timeline plausible, the claim consistent with the pattern of suppression evident elsewhere. Within hours, the post was removed by forum moderators, citing lack of verification and potential violation of terms of service. The engineer's account was suspended. Copies of the post circulated on other platforms, but the original source had been eliminated. The pattern repeated what had happened with earlier leaks. Information appears, gains traction, then disappears through mechanisms that leave no official record. No legal actions, no formal takedowns, just quiet removal and account suspensions that prevent follow-up or verification. Meanwhile, Mars-based observation schedules remained publicly accessible through NASA and ESA mission planning databases. These databases showed what instruments were being used, when, and for what purpose. They exist to coordinate scientific research and ensure transparency in how public resources are allocated. On October 28th, researchers began examining these schedules closely. What they found was revealing. During the critical perihelion window, October 29th to the 30th, every Mars orbital asset was scheduled for routine operations. HiRISE was imaging Martian surface features. CASSIS was conducting routine mapping. Perseverance NavCam was focused on local geology. Not a single instrument was scheduled to observe 3I Atlas during the most observationally significant moment of its passage through the solar system. The omission was so glaring, so inconsistent with scientific priorities, that it could only be deliberate. Some researchers attempted to request emergency observation time, arguing that perihelion represented a unique opportunity that would never recur. The requests were denied, citing mission priorities and scheduling constraints. The rationale was technically correct. Mission schedules are set months in advance and rarely changed, but applying such rigid procedures to an unprecedented event seemed like bureaucracy weaponized against discovery. The Mars window wasn't just being ignored. It was being actively avoided, as if someone had decided that detailed observation during perihelion would be counterproductive, would generate data that complicated rather than clarified the situation. That decision suggested something profound about what institutions expected to happen. If perihelion were going to be routine, if 3I Atlas would simply heat up and behave like a normal comet, there would be no reason to avoid observation. The data would support the natural origin hypothesis, providing evidence against artificial theories. But if institutions expected non-routine behavior, if they anticipated something that would be difficult to explain through conventional models, then avoiding detailed observation made tactical sense. What isn't documented can't be proven. What isn't measured can remain ambiguous. Ambiguity preserves flexibility, allows institutions to maintain narrative control. The missing Mars window was therefore evidence not of what was known, but of what was expected. Someone, somewhere, with authority over multiple space missions, had concluded that detailed observation of 3I Atlas during perihelion was undesirable. That conclusion implied expectation of anomalous behavior that would be difficult to suppress if captured in high-resolution imagery by instruments whose data normally flowed directly to public archives. By the evening of October 28th, amateur astronomers were preparing their own observation campaigns. Without access to orbital platforms or professional observatories, they would make do with backyard telescopes and privately funded instruments. The quality would be inferior, the data less definitive, but it would be something. A record that couldn't be classified or suppressed. Coordination was happening through encrypted channels, through forums that had learned to avoid easy surveillance. Times were being synchronized, observation protocols were being standardized. Plans were being made to share data across networks that couldn't be easily interrupted. It was, in a strange way, a return to astronomy's roots. Before, government agencies and billion-dollar observatories, before institutional science and peer review, individuals watched the sky and recorded what they saw. The professionalization of astronomy had brought rigor and precision, but it had also created structures that could be controlled, that could be pressured into silence. Amateur observers couldn't be controlled the same way. They had no careers to threaten, no funding to withdraw, no institutions to pressure. They were the informational immune system that activated when official channels failed. As October 29th dawned, the question wasn't whether 3I Atlas would be observed during perihelion. It was whether amateur observations would be sufficient to document whatever happened, and whether that documentation would be credible enough to challenge institutional narratives. The missing Mars window had created an observational vacuum that was about to be tested. If perihelion produced nothing unusual, the vacuum wouldn't matter. But if something extraordinary occurred, the decision to fly blind would be revealed as strategic rather than incidental, and in that revelation, the coordinated silence would transform from defensive caution into evidence of something darker. The deliberate suppression of discovery, the calculated prevention of knowledge, the choice to leave humanity ignorant rather than risk revealing truths deemed too disruptive to acknowledge. The 12 hours before perihelion felt like a breath held too long. October 29, 2025, 06 UTC. In 12 hours, 3I Atlas would reach its closest approach to the Sun, 0.32 astronomical units, roughly 48 million kilometers from the solar surface. For comparison, Mercury orbits at 0.39 AU. 3I Atlas was going to pass inside Mercury's orbit, exposing itself to solar radiation intense enough to vaporize volatile compounds and stress any structure to its limits. Natural comets undergoing perihelion often fragment. The thermal gradient between sun-facing and shadow sides creates mechanical stress. Volatile ices sublimate rapidly, creating thrust that can split weakly bonded material. Many comets have been observed to break apart during close solar approaches, turning from single objects into debris clouds. If 3I Atlas were a natural comet, fragmentation was possible. If it were artificial, if it were held together by engineered materials and designed structures, it might survive intact. The difference would be observable, assuming anyone was watching closely enough to notice. Ground-based observation from Earth was impossible during perihelion. The object would be located on the far side of the Sun from Earth's perspective, hidden behind 1.4 million kilometers of stellar mass and surrounded by solar glare. No telescope on Earth could penetrate that geometry. The observation would have to wait until 3I Atlas emerged on the other side, moving outward from the Sun toward the outer solar system. That emergence was calculated for October 30th, approximately 14 hours after perihelion. The exact time depended on the object's velocity and trajectory, both of which were known precisely enough for prediction, but not perfectly enough to eliminate uncertainty. During those 14 hours, 3I Atlas would be invisible. Whatever happened during its closest solar approach would occur without witnesses, without sensors, without any record except whatever the object itself carried through the experience. The timing felt deliberate. An object approaching along the ecliptic, arriving during an era when humanity had space-based observation capabilities, but passing perihelion at a moment when those capabilities were temporarily blind. It was either extraordinary coincidence or careful planning. Amateur astronomers were positioning themselves for the emergence. Telescopes across the southern hemisphere, where October 30th would bring darkness during the predicted emergence window, were being prepared. Networks had formed. Plans for rapid data sharing, protocols for verification. If something extraordinary occurred, if 3I Atlas emerged looking different, behaving differently, or not emerging at all, the amateur community was prepared to document it. But 12 hours before perihelion, something else happened that shifted attention away from the sky. On October 29th, 06:15 UTC, the website for the International Astronomical Union went offline. The IAU serves as the central authority for astronomical nomenclature, coordinates international research efforts, and maintains databases of celestial objects. It's not a high-security target, not the kind of system that typically faces sophisticated attacks. The outage was announced as routine maintenance, scheduled work, system updates, expected to be resolved within hours. But the timing, occurring precisely as global attention focused on 3I Atlas, felt suspicious. By 08 Rigu UTC, other astronomy-related websites had also gone dark. The Minor Planet Center, which tracks asteroids and comets, became inaccessible. The SETI Institute's website returned error messages. The Planetary Society, a public advocacy organization for space exploration, suddenly displayed maintenance notices. Each outage individually could be coincidental. Multiple organizations conducting maintenance simultaneously seemed improbable, but not impossible. But the pattern created a blackout of information sources precisely when public interest in interstellar objects was peaking. Social media filled with speculation about cyber attacks, about coordinated efforts to disrupt information flow, about governments attempting to control the narrative by eliminating independent sources. The speculation was probably excessive, attributing to malice what incompetence or coincidence could explain, but the timing made skepticism reasonable. By 10 Mal UTC, mainstream media began covering the website outages, treating them as a technology story rather than connecting them to 3i Atlas. Articles discussed cybersecurity vulnerabilities, the importance of backup systems, the need for better digital infrastructure. The connection to perihelion went unmentioned, as if the timing were irrelevant. Alternative media made the connection explicitly. Live streams discussed the outages as evidence of suppression, as confirmation that institutions were actively preventing public access to information about 3i Atlas. Whether that interpretation was accurate or paranoid was impossible to determine, but it reflected a collapse of trust in official narratives. By noon UTC, 6 hours before perihelion, most of the affected websites had been restored. The IAU announced that maintenance had been completed successfully. The Minor Planet Center resumed operations. SETI's website returned to normal. Apologies were issued for any inconvenience, with assurances that all systems were now functioning properly. The outages had lasted approximately 6 hours, during which time anyone seeking information about interstellar objects would have found major authoritative sources unavailable. The blackout hadn't prevented information flow entirely. Alternative sources and cached data remained accessible, but it had disrupted the normal channels through which astronomical information typically spreads. Whether deliberate or coincidental, the outages had created informational confusion during a critical period, and confusion serves suppression nearly as well as overt censorship, making it difficult for people to access reliable information, forcing them to rely on secondary sources or wait for restoration. As afternoon arrived in various time zones, observers around the world began their waiting. Telescopes were aligned, cameras were prepared, networks were tested. The plan was simple: watch for emergence, document whatever appeared, share data immediately across platforms that couldn't easily be shut down simultaneously. The amateur network represented something institutions hadn't fully accounted for. In an earlier era, space observation was effectively monopolized by government agencies and major universities. The equipment was too expensive, the expertise too specialized, the data processing too computationally intensive for individuals or small groups. But technology had democratized observation. High-quality telescopes had become affordable. CCD cameras and data processing software had become accessible. Amateur astronomers could now capture images and conduct analysis that would have required institutional resources just decades earlier. This democratization created resilience against suppression. You could pressure NASA into silence. You could classify data from orbital observatories. You could deny telescope time to professional researchers. But you couldn't stop hundreds of amateur observers scattered across continents from pointing instruments skyward and sharing what they saw. The period between perihelion and emergence represented a gap in that observational coverage, but it also represented a test of institutional narrative. If 3i Atlas emerged looking and behaving exactly as a natural comet should, the amateur network would document that reality. If it emerged with anomalies, with changes suggesting non-natural properties, that reality would also be documented. Institutions had chosen to fly blind during perihelion itself, but they couldn't prevent observation of the aftermath. Whatever 3i Atlas looked like after its close solar approach would be visible to anyone with adequate equipment and clear skies. By 15 UTC, 3 hours before perihelion, solar observatories around the world were monitoring the sun's corona, the outer atmosphere visible during the time around perihelion. The SOHO spacecraft, positioned at the L1 Lagrange point between Earth and Sun, maintained continuous solar observation. Its coronagraph could potentially image 3I Atlas during perihelion if the object passed through the right region of space. SOHO data streams were public, available in real time to anyone interested in solar observation. If something unusual occurred during perihelion, if 3I Atlas behaved anomalously or interacted with the solar environment in unexpected ways, SOHO might capture it. The spacecraft wasn't designed for tracking small objects. Its purpose was solar science, but its position and capabilities made it a potential witness to whatever happened behind the sun. As the final hours counted down, the mood in online observation communities shifted from speculation to anticipation. The theories, the arguments, the statistical analyses had brought the conversation to this point. Now came the moment of observation, when reality would either confirm or contradict the accumulated evidence suggesting 3I Atlas was something extraordinary. In the waiting, there was a strange calm. Either the world was about to witness evidence of artificial objects from other civilizations, or it was about to see a natural comet complete an unremarkable perihelion passage. Either outcome would be definitive, would end uncertainty, would answer questions that had consumed thousands of people for months, except that uncertainty, as events would demonstrate, is remarkably difficult to eliminate. And definitive answers require observation, documentation, and verification that institutions had spent weeks ensuring would be as difficult as possible to obtain. At 1807 UTC on October 29, 2025, 3I Atlas reached perihelion. The moment passed without fanfare, without observation, without any immediate indication that anything significant had occurred. The object was behind the sun, swallowed by distance and glare, invisible to every instrument on Earth and most instruments in space. The SOHO spacecraft, humanity's closest witness, captured images of the solar corona every 12 minutes. Amateur observers monitoring the real-time data stream watched as frame after frame showed nothing unusual. The sun's atmosphere rippled and flared with its characteristic plasma dynamics. No anomalous objects appeared in the coronagraph's field of view. By 1930 UTC, over an hour past perihelion, observers began noting the absence. 3I Atlas should have been visible somewhere in SOHO's imaging, even briefly. The trajectory calculations had been precise enough to predict its path through the corona's outer regions, yet nothing appeared that could definitively be identified as the interstellar object. 2. Possibilities emerged. Either 3I Atlas had passed through a region not covered by SOHO's instruments, which was plausible given the limited field of view, or it had fragmented completely during perihelion, breaking apart under thermal and gravitational stress into pieces too small for detection. Fragmentation would support the natural comet hypothesis. Comets are fragile assemblages of ice and dust, held together by weak gravitational attraction and frozen volatiles. Subjecting such an object to perihelion heating often results in catastrophic breakup. If 3I Atlas had disintegrated, it would confirm it was natural, would end the speculation about artificial origin. But fragmentation would also eliminate the object as an ongoing mystery. If 3I Atlas no longer existed as a coherent body, there would be nothing left to observe, nothing to track as it moved outward from the sun, nothing to study or analyze. The story would end not with revelation, but with dissolution. By 22 AKSH UTC 4, hours past perihelion, attention shifted to emergence tracking. Observers in the southern hemisphere were preparing for darkness, positioning telescopes to capture the region of space where 3I Atlas should reappear. The calculations predicted emergence around 0800 UTC on October 30th, approximately 14 hours after perihelion. The waiting period felt longer than it should. Hours stretched as observers checked equipment, monitored weather conditions, shared nervous speculation in chat rooms and forums. The accumulated tension of weeks was focusing on a single moment. Would 3I Atlas emerge intact? At 23:47 UTC, something unexpected appeared in SOHO data. A frame from the LASCO C3 coronagraph showed a faint streak in the outer corona, positioned roughly where 3I Atlas's trajectory should have placed it. The streak was small, barely distinguishable from background noise, but its motion across subsequent frames matched the expected velocity. Amateur analysts immediately began processing the images, enhancing contrast, filtering noise, attempting to extract maximum information from the limited data. The streak appeared to show structure, not the diffuse blur of a debris cloud, but something more coherent. It was impossible to determine size or shape from SOHO's resolution, but the mere presence of something suggested the object had survived perihelion, at least partially intact. The discovery energized observation networks. If 3i Atlas was still coherent, still moving, as a single object rather than a dispersing cloud, emergence would provide the critical data point. The object would have been subjected to extreme thermal stress, to solar wind, to gravitational tidal forces. How it responded to those stresses would reveal much about its composition and structure. Natural comets emerging from close perihelion typically show enhanced activity. The thermal energy absorbed from the sun drives vigorous outgassing, creating bright comas and extended tails. The comet becomes more visible, more dramatic, easier to observe. If 3i Atlas emerged with enhanced activity, it would suggest natural composition responding normally to solar heating. But if it emerged unchanged, showing no increased activity, no enhanced outgassing, no visible effects from perihelion passage, that would suggest something else. Materials that could withstand such thermal stress without degradation would imply engineered heat resistance, designed thermal management, properties incompatible with natural comet composition. As October 30th began in various time zones, the observation network went active. Telescopes across South America, Southern Africa, Australia, and New Zealand pointed toward the calculated emergence coordinates. The weather was cooperating in most locations, clear skies providing optimal viewing conditions. At 07:15 UTC, 45 minutes before predicted emergence, an astronomer in Chile reported visual acquisition. Through a 20-inch telescope, they'd captured what appeared to be 3i Atlas, emerging from solar glare earlier than calculated. The object appeared faint but distinct, moving on the expected trajectory. Other observers quickly confirmed. Multiple telescopes across different continents acquired the object within minutes. The rapid confirmation suggested it was indeed 3i Atlas and not a misidentified star or instrumental artifact. The object was back, visible, available for observation. But something was wrong. The object appeared dimmer than expected. Based on pre-perihelion brightness and assuming normal cometary behavior, 3i Atlas should have emerged brighter, energized by solar heating. Instead, it looked fainter, as if perihelion had somehow reduced rather than enhanced its visibility. Spectroscopic analysis began immediately. Multiple observers captured spectra, looking for signs of outgassing, for chemical changes, for evidence of how perihelion had affected the object's composition. The data would take time to process and analyze, but preliminary observations showed minimal emission lines. The object wasn't outgassing significantly, despite having just passed through intense solar heating. By 09:00 UTC, high-resolution imaging was being attempted by observers with adequate equipment. The images were still limited by atmospheric distortion and distance, but they showed structure. The object remained elongated, maintaining its cylindrical appearance. There were no obvious signs of fragmentation, no debris cloud, no indication that perihelion had broken it apart. The intact emergence was itself significant. Natural comets that survive perihelion often show visible damage, chunks carving off, structural changes apparent in subsequent imaging. 3i Atlas looked essentially identical to pre-perihelion observations, as if the close solar approach had left no mark. Then came the velocity anomaly. Careful tracking of the object's position across multiple observations revealed something troubling. 3i Atlas was moving slightly faster than predicted. The difference was small, less than 1% of its total velocity, but it was measurable and consistent across independent observations. Perihelion passage shouldn't accelerate an object beyond what orbital mechanics predicts. The gravitational interaction with the Sun is precisely calculable. Any deviation from calculated velocity requires explanation. Natural outgassing can provide small accelerations, the rocket effect of venting gas, but 3I Atlas wasn't showing significant outgassing. The velocity anomaly suggested something had happened during perihelion that imparted additional momentum. A course correction, a propulsive event, something that changed the object's trajectory in ways that natural processes couldn't easily explain. By midday UTC on October 30th, the amateur observation network had documented several clear anomalies: intact survival of perihelion without visible damage, reduced rather than enhanced brightness, minimal outgassing despite intense solar heating, and unexplained velocity increase. Each anomaly individually might be explainable through unusual but natural processes. Together, they formed a pattern increasingly difficult to reconcile with the natural comet hypothesis. Yet official sources remained silent. No space agencies issued statements about the emergence. No professional astronomers published observations or analysis. The institutional blackout that had characterized the approach to perihelion continued into the post-perihelion period, as if nothing significant had occurred. The contrast between amateur documentation and institutional silence was stark. Hundreds of observers across continents had captured data, shared images, conducted analysis, and reached preliminary conclusions suggesting anomalous behavior. Meanwhile, agencies with far superior equipment and expertise published nothing, acknowledged nothing, engaged with none of the accumulating evidence. The silence after emergence felt different from earlier silence. Before perihelion, institutions could claim they were waiting for better data, for the critical observation window, for definitive information. After perihelion, with clear anomalies documented by multiple independent sources, continued silence looked less like caution and more like denial. Something had happened behind the sun, during those hours when no instruments could watch, when 3I Atlas was invisible. To human observation, the object that emerged wasn't behaving like the object that went in. The changes were subtle but measurable, suggesting perihelion had been more than just a close solar pass. And in the continued silence from institutions that should have been shouting about these discoveries, in the absence of engagement from professional astronomers who should have been racing to analyze the data, a darker possibility was emerging. Perhaps institutions weren't silent because they didn't know what was happening. Perhaps they were silent because they did know, and what they knew was something the public wasn't meant to understand. October 30th, 2025, 16. UTC. 9 hours after emergence, and the amateur observation network had accumulated enough data to reach disturbing conclusions. 3I Atlas wasn't just anomalous, it was becoming more anomalous with every passing hour, behaving in ways that strained natural explanation past the breaking point. The velocity change had been confirmed by multiple tracking stations. The object was moving 0.7% faster than pre-perihelion calculations predicted. That might sound trivial, but in orbital mechanics, such changes don't occur without cause. Something during perihelion had altered the trajectory in ways that gravitational interaction alone couldn't explain. One astronomer in Germany calculated the energy required for such a velocity change. For an object with 3I Atlas's estimated mass, approximately 4 million kilograms based on size and assumed density, accelerating by 0.7% of its 26.3 kilometers per second velocity, would require roughly 40 billion joules of energy. That's equivalent to 10 tons of TNT, or the energy output of a small power plant running for several hours. Natural outgassing couldn't provide that much thrust. Even the most active comets, venting material at high rates, produce accelerations orders of magnitude smaller. The only natural phenomenon that could impart such energy would be a close gravitational encounter with a massive body. But 3I Atlas had encountered nothing except the sun, and that interaction was fully accounted for in trajectory calculations. The velocity change implied propulsion, something pushing the object, imparting momentum, changing its course in controlled ways. And propulsion implied technology, implied intent, implied something incompatible with natural origin. By evening, UTC spectroscopic data was being published across amateur networks. Multiple observers had captured high-resolution spectra, showing the object's chemical composition in detail. The nickel signatures remained, still without corresponding iron. But now additional anomalies appeared in the spectra. There were emission lines corresponding to ionized silicon, appearing at wavelengths around 385 nanometers and 413 nanometers. Silicon in cometary spectra isn't impossible. Silicon compounds exist in protoplanetary material, but ionized silicon requires high temperatures or energetic processes. The object wasn't hot enough from solar heating alone to produce significant silicon ionization. The spectroscopic profile looked less like a comet and more like industrial slag, like the emission spectrum you'd expect from metal manufacturing or high-temperature materials processing. Natural objects don't produce such signatures without extreme conditions like volcanic activity or impact events, neither of which applied to 3I Atlas's situation. One chemist, analyzing the spectra, noted that the combination of nickel, ionized silicon, and the thermal properties observed pre-perihelion suggested heat-resistant alloys. The kind of materials you'd engineer for spacecraft exposed to extreme temperatures, designed to withstand solar radiation without degrading or outgassing. By October 31st, less than 48 hours after perihelion, the accumulated evidence had reached critical mass. The trajectory precision, the structural geometry, the impossible chemistry, the thermal contradictions, the velocity anomaly, the spectroscopic signatures, all pointed in the same direction. 3I Atlas wasn't a natural object, it was artificial. That conclusion remained unofficial. No institution had confirmed it. No peer-reviewed paper had been published, making the claim explicitly. But among those who had followed the data, who had watched the accumulation of anomalies, who had seen institution after institution refuse to engage with the evidence, the conclusion felt inevitable. The question was no longer whether 3I Atlas was artificial. The question was what it was for, where it came from, and why institutions were pretending otherwise. Sometimes, in the midst of cascading revelations and institutional silence, it's worth pausing to consider what discovery actually means. Not the technical details, not the political implications, but the fundamental human experience of encountering something that shouldn't exist according to everything we thought we understood about the universe. Humanity has been looking at the stars for as long as eyes could see them. Ancient civilizations mapped constellations, tracked planetary movements, built monuments aligned to celestial events. For millennia, the sky was a constant, predictable, knowable. Comets appeared and disappeared, meteors streaked across darkness, but everything followed patterns that could be learned and predicted. The scientific revolution didn't change that fundamental relationship. It refined it, made it more precise, replaced mythology with mathematics. But the sky remained what it had always been, a place humans observed but didn't participate in. We were audience, not actors. The universe performed its ancient dance, and we watched from our planetary theater seat. 3I Atlas represented something different. For the first time in human history, we were potentially observing an object that observed back, not in the mystical sense of consciousness or awareness, but in the functional sense of purpose and design. If the object was artificial, if it was a probe from another civilization, then it wasn't just passing through our solar system. It was here deliberately, collecting data, perhaps transmitting findings, participating in the cosmic story, rather than simply existing within it. That shift in perspective was profound. It meant the universe wasn't just a place where life happened to emerge. It meant life emerged, developed technology, built things, and sent those things across interstellar distances for purposes we could only guess at. It meant we weren't alone in the transition from biology to technology, from planetary confinement to space exploration. The implications extended beyond astronomy. If technological civilizations existed elsewhere, if they built probes that visited other stellar systems, then the universe was fundamentally different from the one described in textbooks. It was populated, active, full of intentionality and design. The cosmic silence we'd experienced for decades through SETI programs wasn't because nobody was out there. It was because we'd been looking for the wrong signals, listening at the wrong frequencies, expecting communication when perhaps observation was the actual methodology. Consider what sending an interstellar probe requires. The engineering challenges are immense. You need propulsion systems capable of reaching fractional light speed or accepting journey times measured in centuries or millennia. You need power systems that function reliably across those timescales. You need materials that withstand interstellar radiation, micrometeor impacts, and the thermal extremes of both deep space and close stellar approaches. You need autonomy, because signals take years to travel interstellar distances, making real-time control impossible. The probe must make decisions, adjust course, respond to unexpected situations without guidance from its creators. That implies artificial intelligence, sophisticated enough to handle complex scenarios, robust enough to function after centuries in the void. And you need purpose. Nobody invests such resources without reason. A civilization capable of building and launching interstellar probes would do so because they valued the knowledge gained, because understanding other stellar systems, other planets, potentially other civilizations, was worth the immense investment. What would such a probe be looking for? Perhaps planets capable of supporting life, perhaps signs of technological development, perhaps radio transmissions, atmospheric composition changes, artificial structures visible from space. All the signals that would indicate a planet wasn't just geologically active, but biologically inhabited and technologically advancing. Earth has been broadcasting its presence for over a century. Radio signals, television broadcasts, radar installations, all leaking into space at the speed of light, creating an expanding sphere of electromagnetic noise that says technology exists here. Any probe passing within detection range would identify those signals immediately, would recognize them as artificial, would potentially alter course to investigate. 3I Atlas's trajectory, its precise ecliptic alignment, its timing to pass near Earth and Mars during an era when both planets showed clear signs of technological civilization, could be exactly that kind of investigative approach. First detection of radio signals decades or centuries ago, then course adjustment, then arrival time to observe without immediately threatening. The 1977 WOW signal, if connected to 3I Atlas as the timing suggested, might have been exactly that announcement. A transmission at hydrogen frequency, the universal marker saying, "We're coming, we detected you, this is what we are." A polite knock before entering, giving the local civilization time to notice and prepare. But preparation implies knowledge, and knowledge requires acknowledgement. If institutions were suppressing evidence of 3I Atlas's artificial nature, they were preventing humanity from preparing for whatever came next. They were choosing ignorance over readiness, control over truth, maintaining current social and political structures over adapting to new cosmic realities. That choice, if it was being made, reflected deep uncertainty about how humanity would respond to confirmation of extraterrestrial technology. Would it unite nations in common wonder? Would it trigger panic and social breakdown? Would it undermine religious frameworks, political authority, economic systems built on assumptions of human uniqueness and cosmic isolation? History offered mixed guidance. Past revelations that challenged fundamental beliefs had sometimes triggered violence and resistance. Galileo was tried for suggesting Earth wasn't the center of the universe. Darwin's theories of evolution faced decades of opposition. Even today, demonstrable scientific facts were rejected by populations unwilling to accept implications that threatened ideological commitments. Confirming artificial interstellar objects might trigger similar resistance, amplified by the stakes involved. It wasn't just challenging pride or religious doctrine. It was confirming that humanity occupied a universe populated by others, potentially others far more technologically advanced, others who might view us as we view primitive tribal societies, interesting but not peers. That realization could be humbling or terrifying depending on perspective. It could inspire renewed effort toward advancement or resignation that we'd never match capabilities demonstrated by entities capable of crossing interstellar space. It could foster unity through recognition of shared human identity against cosmic context, or fracture societies as different groups interpreted the implications differently. Maybe institutions were genuinely trying to protect social stability. Maybe they had concluded that truth, in this case, was less important than preventing panic. Maybe they believed that acknowledging 3I Atlas's artificial nature would cause more harm than suppressing evidence, and they'd made a calculated decision to sacrifice transparency for security. Or maybe they simply didn't know how to handle a situation for which no protocols existed. First contact scenarios had been theorized for decades, but always assuming radio signals, assuming distance and delay, assuming time to formulate responses. A physical object in the solar system, observable, proximate, potentially collecting data and transmitting findings, didn't match the assumptions underlying those protocols. The breathing space between perihelion and whatever came next offered time for reflection. Time to consider not just what 3I Atlas might be, but what humanity's response should be if artificial origin was confirmed. Time to think about disclosure strategies, about how information should be shared, about whether truth served the public interest or threatened it. But time was limited. 3I Atlas was moving outward from the Sun, heading toward the outer solar system on its continuing journey. Amateur observers were tracking it, documenting behavior, accumulating evidence. The institutional silence that had contained information so far was showing cracks, failures in coordination, leaks that suggested internal disagreement about suppression policies. Eventually, someone with access to classified data would break ranks. Someone would decide that truth mattered more than career, that humanity deserved knowledge, regardless of institutional preference for ignorance. When that break occurred, when confirmation came from credible sources with access to the highest quality data, the conversation would shift irreversibly. The question was whether institutions would get ahead of that shift, would choose disclosure on their terms rather than having it forced upon them, or whether they'd maintain silence until the situation was taken out of their hands, until amateur evidence became overwhelming, until suppression collapsed under its own weight. In the breathing space of uncertainty, both futures remained possible, but the window for choosing was closing. And once events forced the choice rather than allowing it to be made deliberately, control would be lost entirely, replaced by chaos that might have been avoided through earlier honesty. The stars had been watching us for as long as we'd been watching them. Perhaps it was time to acknowledge that the watching went both ways, and that cosmic isolation had always been an illusion maintained by distance rather than confirmed by absence. On November 1st, 2025, a post appeared on Reddit's Our Astronomy subreddit that transformed amateur tracking into predictive science. A user with the handle Orbital Mechanic PhD published a detailed trajectory analysis of 3I Atlas's post-perihelion path, including calculations showing where the object would be in the coming weeks and months. The analysis was sophisticated, using orbital dynamics software typically employed by professional mission planners. The user had taken amateur observations from multiple sources, synthesized position and velocity data, and calculated the object's future trajectory with impressive precision. The projections showed 3I Atlas moving outward from the Sun at its increased velocity, heading toward the outer solar system on a path that would eventually carry it back to interstellar space. But embedded in the trajectory analysis was something that made moderators immediately flag the post. According to the calculations, 3I Atlas would pass within 0.8 astronomical units of Earth in late November, approximately 120 million kilometers away. For comparison, Mars at its closest approach gets within about 55 million kilometers. This wouldn't be a close flyby by asteroid standards, but it would be close enough for detailed observation from Earth-based instruments. More significantly, the trajectory showed the object would pass through a region of space currently occupied by several communications satellites in high Earth orbit. Not dangerously close, space is vast even at those altitudes, but close enough that the satellite sensors would capture data automatically as part of their standard operation. The post included specific dates and coordinates. November 23, 2025, approximately 14:30 UTC, 3i Atlas would reach its point of closest approach to Earth. During a window spanning several hours before and after, ground-based telescopes would have optimal viewing geometry, free from solar glare and atmospheric interference at favorable elevation angles. Within hours, the post had accumulated thousands of upvotes and comments. Amateur astronomers began planning coordinated observation campaigns. Dates were marked on calendars. Equipment was being prepared. The November 23rd window became a focal point, a second chance at the kind of detailed observation that should have occurred during perihelion, but had been prevented by geometry and institutional silence. Then something unusual happened. The post was removed by subreddit moderators. The official explanation cited violation of community guidelines, specifically rules against speculative content not backed by peer-reviewed sources. The removal was standard moderation practice, but the timing felt suspicious given how quickly it occurred and how thoroughly the post was researched. Orbital Mechanic PhD attempted to repost with additional verification, including links to the orbital mechanics software used and detailed methodology. That post was also removed, this time with the account temporarily banned for repeatedly violating community standards. The trajectory data disappeared from the subreddit as if it had never existed. But the internet doesn't forget easily. Screenshots of the original post circulated across platforms. The trajectory calculations were copied and shared through forums, chat servers, and social media. Within 24 hours, multiple astronomers had independently verified the calculations, confirming that yes, 3i Atlas would indeed pass close to Earth in late November, and yes, the observation window would be optimal. The removal and subsequent ban suggested something troubling. If the trajectory analysis was wrong, moderators would typically leave it up with corrections posted in comments. Removing accurate scientific analysis implied external pressure, implied someone didn't want that information spreading, implied the November approach was considered sensitive. Professional astronomers began privately discussing the implications. A close Earth approach meant unavoidable observation. Every major observatory would have a clear view. Amateur observers across multiple continents would be tracking the object. Satellite sensors would automatically capture data. There would be no way to prevent documentation of whatever 3i Atlas looked like, how it behaved, what signals it might emit. If institutions had been suppressing evidence of anomalous behavior, the November approach would end that suppression. The object would be too close, too observable, too documented by too many independent sources to maintain narrative control. Whatever truth existed about 3i Atlas's nature would emerge through sheer volume of observation. That realization created urgency in institutional responses. On November 2nd, NASA issued its first official statement about 3i Atlas since the original discovery announcement. The statement was brief, technical, carefully worded. It acknowledged the object's interstellar origin, described it as a comet following expected trajectory through the solar system, and noted that additional observations were planned as the object's distance from the Sun increased. The statement made no mention of anomalies, no acknowledgement of amateur observations documenting unusual behavior, no response to questions about why better imagery hadn't been released. It read like a standard mission update, as if nothing controversial had occurred, as if months of speculation and accumulated evidence simply didn't exist. The tone-deaf response generated immediate backlash. Comment sections filled with questions NASA didn't answer. Why hadn't better images been released? What explained the velocity anomaly? Why were Mars-based assets not observing during perihelion? The statement's refusal to engage with actual points of controversy made it feel less like information and more like propaganda. ESA followed with a similar statement the next day, also brief, also avoiding substantive engagement with documented anomalies. The coordination in messaging suggested the agencies were following agreed-upon protocols, presenting unified narrative regardless of what data actually showed. Meanwhile, amateur networks were coordinating their own response. The November 23rd observation campaign was being organized across time zones and continents. Protocols were being established for data collection, sharing, and verification. Equipment was being tested and calibrated. The amateur community was preparing to conduct the kind of comprehensive observation that institutions should have conducted but hadn't. One element of the amateur campaign stood out as particularly sophisticated. A group of radio astronomers using privately owned antenna arrays planned to attempt detection of any electromagnetic emissions from 3I Atlas during closest approach. If the object was transmitting, if it was broadcasting data or signals of any kind, the November window would provide optimal geometry for detection. The radio observation plan specifically targeted 1420.4556 MHz, the hydrogen line frequency associated with the WOW signal. If 3I Atlas had sent that signal decades earlier, if it was still broadcasting at the same frequency, a close Earth approach would put sensitive receivers within optimal range for detection. The amateur network would definitively confirm or refute the connection between 3I Atlas and the 1977 transmission. Professional SETI researchers, despite having far superior equipment, announced no plans to conduct similar observations. The omission was glaring. SETI's entire purpose was detecting potential artificial signals from space. An object with suspected artificial origin passing close to Earth should have triggered immediate observational response. The silence suggested either profound skepticism about 3I Atlas's significance or instructions not to observe. By mid-November, tension was building toward the approach date. Media coverage increased, though mainstream outlets continued framing the story as interesting rather than potentially revolutionary. Alternative media treated it as confirmation of government cover-up, as vindication of theories that had been dismissed as conspiracy. The truth, as usual, was probably more complex than either. Narrative allowed. Institutions weren't necessarily covering up confirmed alien technology, but they also weren't engaging honestly with documented anomalies. The pattern suggested something in between, genuine uncertainty about what 3I Atlas represented, combined with institutional preference for caution over transparency, for controlled narrative over open investigation. As November 23rd approached, the question wasn't whether 3I Atlas would be observed. The question was whether observation would finally provide definitive answers or simply generate more sophisticated ambiguity. November 18th, 2025. 5 days before closest approach, and something disturbing was happening in high Earth orbit. Communications satellites that should have been operational, that had been functioning normally for years, were going offline without explanation. The first to disappear was a commercial weather satellite operated by a European consortium. On November 17th at 22:15 UTC, telemetry from the satellite simply stopped. Mission control received no warnings, no error messages, no indication of malfunction. The satellite had been transmitting normally, then nothing. Radio contact attempts received no response. The satellite had gone dark. By itself, a satellite failure wasn't unprecedented. Space is a harsh environment. Micrometeorite impacts, radiation damage, electronic failures, all can disable spacecraft without warning. But the timing, occurring days before 3I Atlas's closest approach along a trajectory that would pass near the satellite's orbital position, made coincidence feel unlikely. The second satellite went dark on November 18th. This one was a Japanese Earth observation platform, positioned in geostationary orbit to monitor Pacific weather patterns. Same pattern, normal operations, then sudden silence, no warnings, no errors, no response to ground commands, just absence where functioning technology should have been. By November 19th, 4 satellites had gone offline. All were positioned in orbital regions that 3I Atlas's trajectory would pass through or near. All failed without warning. All became unresponsive to ground control. Space agencies issued statements attributing the failures to solar activity. A coronal mass ejection had occurred on November 16th, releasing charged particles that could disrupt satellite electronics. The explanation was technically plausible. Solar storms do damage spacecraft, can overwhelm shielding, can cause exactly the kind of sudden failures being observed. But solar storms affect satellites indiscriminately. They don't target specific spacecraft in specific orbital positions while leaving others nearby unaffected, and the November 16th CME had been relatively minor, not the kind of event that typically causes multiple satellite failures. Amateur satellite trackers, hobbyists who monitor spacecraft positions and status as a hobby, began noticing additional anomalies. Several military reconnaissance satellites, which normally followed predictable orbits, had maneuvered unexpectedly. Their new orbital parameters positioned them away from 3I Atlas's projected path, as if they'd been deliberately moved to avoid the approaching object. Military satellites don't announce maneuvers publicly, but their orbital changes can be detected through patient observation. The trackers documented at least 6 US military spacecraft and 3 from other nations, making unusual orbital adjustments between November 15th and 19th. All movements were consistent with avoiding 3I Atlas's trajectory. The pattern suggested something beyond solar storm precautions. Satellites were being moved or disabled to clear the path for 3I Atlas's approach. Either someone was protecting satellites from potential damage, or someone was ensuring that certain sensors wouldn't automatically capture data about the object as it passed. On November 20th, 3 days before closest approach, an anonymous post appeared on a satellite engineering forum. The poster claimed to be a mission controller for one of the disabled satellites. According to the post, the satellite hadn't failed. It had been commanded offline deliberately, shut down through ground control systems to prevent it from collecting data during the November 23rd window. The post included technical details about the shutdown sequence, information that would be difficult for someone without access to mission control systems to fabricate. It described specific command protocols, authentication procedures, and the precise timing of the shutdown relative to 3I Atlas's approach. If accurate, the post confirmed deliberate action rather than coincidental failure. Satellites were being disabled not because they were at risk, but because their sensors might document something that wasn't meant to be documented. The clearing of orbital space wasn't protective, it was preventive. Verification was impossible through official channels. No space agency acknowledged deliberate satellite shutdowns. No mission controller confirmed the post's claims, but the technical accuracy of the details lent credibility, suggested the poster had genuine inside knowledge. By November 21st, amateur observers were tracking not just 3I Atlas, but the constellation of satellites around Earth, documenting which remained operational and which had gone dark. The map that emerged showed a clear corridor being created, a region of space that would normally be densely monitored by multiple satellites, now largely devoid of functioning sensors. The corridor corresponded exactly to 3I Atlas's projected path during closest approach. Every satellite positioned to automatically capture high-resolution imagery or electromagnetic data as the object passed had been disabled or maneuvered away. The deliberate nature of the pattern was undeniable. One implication was chilling. If institutions were clearing satellite coverage to prevent automated data collection, they expected 3I Atlas to do something during closest approach that they didn't want documented. They weren't just avoiding observation. They were actively preventing it, accepting the loss of operational satellites and the disruption of their missions to ensure specific data wouldn't be captured. What could 3I Atlas do that would warrant such extreme measures? The possibilities ranged from mundane to extraordinary. Perhaps it would maneuver, demonstrating propulsion capabilities that would confirm artificial origin. Perhaps it would emit signals, broadcasting data or communications that would be intercepted by satellite receivers. Perhaps it would deploy something, releasing sub-probes or instruments that would be visible to high-resolution sensors. Or perhaps institutions simply didn't know what would happen, but had concluded that uncertainty favored prevented observation over documented surprise. Better to have no data than data that couldn't be explained, data that would force acknowledgement of something they weren't prepared to acknowledge. The missing satellites created a paradox. The very act of clearing observation platforms signaled that something significant was expected. If 3I Atlas were just a comet, if closest approach would be routine and unremarkable, there would be no reason to disable satellites and disrupt their operations. The elaborate effort to prevent observation was itself evidence that observation might reveal something extraordinary. Amateur. Networks responded by intensifying their own preparations. If official assets were being deliberately blinded, then independent observation became even more critical. The November 23rd campaign expanded to include radio monitoring, electromagnetic spectrum analysis, and coordinated imaging across as many platforms as could be organized. Professional astronomers, operating outside institutional constraints, were quietly preparing their own observations, not through official channels, not using government-funded equipment, but through personal telescopes and private observatories. The community had fractured into those following institutional guidance and those choosing independent investigation. As November 22nd arrived, less than 48 hours before closest approach, the atmosphere felt like waiting for a storm everyone could see coming, but nobody could predict. The missing satellites had transformed anticipation into certainty that something would happen. The question was only, what? And whether independent observers would be able to document it despite institutional efforts to prevent observation. The sky was being cleared, but not the way it should be for routine science. It was being cleared the way you clear civilians before a military operation, the way you establish exclusion zones before testing weapons, the way you prevent witnesses before doing something you don't want witnessed. And the object at the center of that cleared space, moving steadily closer to Earth, was either a natural comet being treated with absurd overcaution or something else entirely, something important enough that preventing documentation was worth crippling satellite infrastructure and abandoning the pretense that institutions valued transparency. November 23, 2025, 14:30 UTC. 3I Atlas reached its closest point to Earth, 0.8 astronomical units away, approximately 120 million kilometers. That's roughly the distance from Earth to Venus at their closest approach. Far enough that the object remained a point of light even in powerful telescopes, but close enough that detailed spectroscopy and careful observation could extract meaningful data. The amateur observation network activated at dawn across the southern hemisphere, where November 23rd brought clear skies and optimal viewing angles. Telescopes from Chile to Australia to South Africa pointed skyward. Cameras recording, spectrographs analyzing, radio antennas listening for any electromagnetic whisper. The first. Reports came from New Zealand at 15 sus UTC. Multiple observers confirmed visual acquisition, tracking 3I Atlas as it moved against the background stars. The object appeared as expected based on recent observations, elongated, faint, showing minimal outgassing. Nothing immediately anomalous, nothing that would obviously justify the satellite clearance and institutional panic. But then came the spectroscopic data, and everything changed. An astronomer in Chile, using a privately owned telescope with sophisticated spectroscopic equipment, captured something extraordinary. The spectrum showed emission lines that shouldn't exist in natural objects. Specific wavelengths corresponding to ionized xenon, appearing at 462.4 nanometers and 467.1 nanometers. Xenon is a noble gas, chemically inert, extremely rare in space. It exists in trace amounts in planetary atmospheres, can be found in some stellar environments, but has no business appearing in the spectrum of an interstellar comet. More. Significantly, ionized xenon requires specific energetic conditions, conditions that occur naturally only in high-energy astrophysical events or in technological applications like ion propulsion systems. Ion drives, the kind used on spacecraft like NASA's Dawn mission and ESA's BepiColombo, work by ionizing xenon and accelerating it electromagnetically to produce thrust. The technology is efficient for long-duration space missions because xenon is heavy and produces good thrust per unit of propellant, but it's decidedly technological, decidedly artificial, decidedly incompatible with natural comet composition. The xenon signature was strong, unmistakable, confirmed by multiple observers using different instruments. It wasn't instrumental artifact or misidentified spectral lines. It was xenon, ionized, present in the emissions from 3I Atlas during closest approach to Earth. Within an hour, the data was circulating through amateur networks, being analyzed by chemists and spectroscopists, being verified and re-verified. The conclusion was unavoidable. 3I Atlas was emitting propellant exhaust. It was actively using propulsion. It was maneuvering. The implications crashed through every remaining argument for natural origin. Natural objects don't carry xenon ion drives. They don't maneuver using technological propulsion. They follow trajectories determined entirely by gravity, by their initial velocity, and the cumulative pull of every massive body they encounter. Propulsion means technology. Technology means artificial construction. Artificial construction means another civilization, another intelligence, another voice in the cosmic conversation. By 16H UTC, radio astronomers monitoring 14 to 20 MHz reported detection. The signal wasn't strong, wasn't the dramatic burst that fictional first contact scenarios always imagined. It was subtle, intermittent, a narrow band emission that faded in and out like someone tapping Morse code from a great distance. The frequency was exact, 1420, 455 MHz, the hydrogen line, the same frequency as the WOW signal. The transmission appeared to be carrying information, showing patterns of intensity variation that weren't random noise. Whether those patterns constituted a message, whether they were data being transmitted to somewhere else, or whether they were simply a beacon saying, "We are here," remained uncertain. But they were artificial. They were intentional. They were communication. The amateur network had done what institutions had spent months preventing. They documented definitive evidence of artificial technology, of active propulsion, of deliberate transmission. The data wasn't ambiguous. It wasn't subject to interpretation or debate. It was observational fact, collected by independent sources, verified across multiple platforms. And yet, as the data began spreading across networks, as news started breaking through alternative media, as the evidence of artificial interstellar technology reached public consciousness, something else was happening simultaneously in the background, something that would demonstrate just how far institutions were willing to go to maintain narrative control. At 1645 UTC, major social media platforms began experiencing unprecedented technical difficulties. Twitter's API slowed to a crawl, making it nearly impossible to share images or data files. Facebook's image upload system returned error messages. Reddit's astronomy and space-related subreddits became inaccessible, displaying maintenance notices. YouTube videos discussing the spectroscopic findings were flagged for violating community guidelines and removed within minutes of posting. The coordinated disruption wasn't total censorship. Text posts still functioned. Conversations continued. But the ability to share the actual observational data, the spectra showing xenon emissions, the radio recordings of the 1420 MHz signal, was being systematically impaired across every major platform simultaneously. The timing was too precise to be coincidental. Within the same hour that definitive evidence of artificial technology was being documented, the infrastructure for sharing that evidence was failing. Not through government order, not through overt censorship that would create legal challenges and public backlash, but through technical issues that could be attributed to system overload or routine maintenance. Amateur observers adapted quickly, moving to encrypted file sharing platforms, to decentralized networks designed to resist censorship, to direct peer-to-peer transfers that didn't rely on centralized infrastructure. The data continued flowing just through channels that required more technical sophistication to access. By 18H UTC, mainstream media outlets had begun covering the closest approach, but their coverage was strangely muted. Articles mentioned amateur observations, acknowledged claims of unusual spectroscopic data, but framed everything with heavy skepticism. Quotes from anonymous astronomers questioned the reliability of amateur analysis, suggested instrumental artifacts, emphasized that no peer-reviewed confirmation existed. The coverage wasn't factually wrong. It was strategically incomplete, presenting just enough information to acknowledge the story while draining it of significance. Readers would come away thinking amateur observers had seen something interesting but probably explainable, nothing that warranted serious attention or concern. One journalist from a major science publication attempted to publish a more detailed analysis of the xenon signatures, including interviews with professional spectroscopists who confirmed the measurements were technically sound. The article was killed by editors before publication, with the journalist later posting on social media that they'd been told the story needed more verification, despite having documentation that would satisfy normal editorial standards. The pattern of soft suppression had evolved into active information warfare, not through government decree or military intervention, but through the subtle manipulation of information infrastructure, editorial decisions, and algorithmic content curation. The truth was being drowned not in lies, but in manufactured uncertainty, in strategic doubt, in the amplification of skeptical voices, and the suppression of confirming evidence. As November 23rd moved into evening across various time zones, 3I Atlas continued, outward from its closest approach point, moving away from Earth on its trajectory toward the outer solar system. The observation window was closing, the object becoming more distant, harder to track, less amenable to detailed study. The data existed. The xenon signatures, the radio transmissions, the trajectory modifications, the velocity anomalies, all documented, all verified by multiple independent sources, all pointing unambiguously toward artificial origin and active operation. But data, without acknowledgement, without institutional validation, without mainstream media coverage, exists in a strange limbo between known and unknown, proven and unproven. By midnight UTC, amateur networks were tallying their observations, compiling comprehensive reports that documented every measurement, every spectrum, every detection. The reports were being distributed through academic channels, sent to professional astronomers, submitted to journals for peer review. Most submissions would be rejected, not because the data was flawed, but because institutions weren't ready to validate conclusions that would force paradigm shifts. But some would get through. Some editors would recognize the significance. Some publications would prioritize truth over institutional comfort. The November 23rd observations had accomplished what months of speculation couldn't. They'd moved the question from, is 3I Atlas artificial, to, why are institutions pretending it isn't? The evidence had become too strong to dismiss, too well documented to ignore, too widely distributed to suppress completely. What remained uncertain was how long the pretense could be maintained, how much institutional credibility would be sacrificed to avoid acknowledgement, and what would finally force the truth into public consciousness in ways that couldn't be managed or controlled. 3I. Atlas was moving away, but the evidence it left behind was spreading through networks that didn't depend on institutional permission or mainstream validation. The truth, once documented and distributed, becomes remarkably difficult to eliminate. It persists, it finds audiences, it waits for the moment when denial becomes more costly than acknowledgement. That moment was approaching. But first, institutions would try one more strategy for maintaining control, one final attempt to shape narrative before events shaped it for them. November 25, 2025, 09, UTC. 2 days after closest approach, and the institutional consensus was fracturing, not publicly, not through official statements or press conferences, but through whispered conversations, through leaked emails, through anonymous posts from people inside agencies who had reached the limit of what conscience would allow them to suppress. The first major leak came from someone inside the European Space Agency, an email chain spanning from early October through late November, discussing observations of 3I Atlas from ESA assets. The emails were heavily redacted, names removed, but the content was explosive. References to non-natural trajectory parameters, discussions of propulsion signatures consistent with ion drive technology, debates about disclosure protocols, and security implications. One email, dated October 12th, contained a line that would define the coming controversy. "We are now certain this is artificial. The question is no longer what it is, but how we manage public knowledge of what we know." The leak appeared on WikiLeaks at 09:17 UTC. By 10 hours, it had been copied across dozens of platforms, archived on decentralized networks, shared through channels that couldn't be easily shut down. The authenticity was immediately disputed by official sources, with ESA issuing a statement claiming the documents were fabricated, but forensic analysis of the email metadata suggested genuine origin from ESA servers. Within hours, similar leaks emerged from other agencies. An internal NASA memo discussing containment strategies for anomalous interstellar object. A classified briefing document from the UK Space Agency describing 3I Atlas as likely probe of extrasolar origin. A JAXA technical report concluding that observed propulsion characteristics cannot be reconciled with natural processes. Each leak independently might have been questioned, might have been dismissed as sophisticated hoaxes created by people with enough technical knowledge to make them convincing. But the sheer volume, the consistency across agencies, the technical specificity of the documents made coordinated fabrication seem less plausible than the alternative. Institutions had known for weeks that 3I Atlas was artificial and had collectively decided to withhold that knowledge. The response from official sources followed predictable patterns: deny authenticity, question verification, emphasize that unconfirmed documents shouldn't be trusted. But the denials felt hollow, felt like people reading scripts they no longer believed, maintaining positions that had become indefensible. By November 26th, cracks were appearing in institutional unity. A senior astronomer at the Harvard-Smithsonian Center for Astrophysics published an opinion piece arguing that the accumulated evidence warranted serious consideration of artificial origin. The astronomer didn't claim definitive proof, didn't explicitly confirm the leaked documents, but broke with the consensus dismissal that had characterized institutional responses. The piece was carefully worded, hedged with qualifications, but its very existence represented a significant shift. A respected figure at a major institution was publicly acknowledging that maybe, possibly, the amateur observations and leaked documents deserved investigation rather than dismissal. It was the first crack in the wall of institutional skepticism. Others followed. An ESA scientist gave an interview to a German publication expressing deep concern about transparency issues surrounding 3I Atlas observations. A Japanese astronomer posted on social media that scientific integrity requires honest engagement with data, regardless of implications. A Russian astrophysicist published a paper analyzing the xenon signatures and concluding they were inconsistent with any known natural process. None made explicit claims of cover-up or conspiracy. None directly confirmed artificial origin, but the pattern showed institutional consensus collapsing, showed individual scientists choosing integrity over institutional messaging, choosing truth over comfortable denial. On November 27th, Avi Loeb published a comprehensive analysis in the Astrophysical Journal, documenting every anomaly associated with 3I Atlas and arguing that the cumulative evidence required acknowledgement of artificial origin as the most parsimonious explanation. The paper was peer-reviewed, technically rigorous, and impossible to dismiss as fringe speculation. Loeb's conclusion was definitive. The object, designated 3I Atlas, displays characteristics inconsistent with natural cometary composition and behavior. Observed propulsion signatures, spectroscopic anomalies, trajectory precision, and thermal properties collectively indicate technological origin. While extraordinary claims require extraordinary evidence, the evidence threshold has been met. Scientific integrity demands acknowledgement that we are observing artificial technology of non-terrestrial origin. The paper's publication represented a watershed moment. A tenured Harvard professor, publishing in a major journal explicitly claiming that humanity had documented an alien probe. The claim was no longer confined to internet forums and amateur networks. It was in peer-reviewed literature, backed by data impossible to ignore. Response from the astronomical community split sharply. Some researchers immediately published rebuttals, arguing that Loeb's analysis overinterpreted ambiguous data, that natural explanations remained possible, that jumping to artificial origin was premature. Others published supporting analyses, adding their own observations to the evidence base, confirming measurements and conclusions. The scientific debate that should have occurred in October, that should have happened as anomalies accumulated, was finally occurring in late November. But it was happening in the context of leaked documents, suppressed data, and institutional credibility already damaged by months of questionable decisions. On November 28th, a group of junior researchers from multiple institutions published an open letter demanding transparency. The letter, signed by over 300 scientists, called for release of all observational data from space-based assets, for independent analysis of institutional findings, for honest public communication about what was known and when it was known. The letter was respectfully worded, but pointedly critical. It noted that science advances through open sharing of data and honest engagement with evidence. The apparent withholding of observations and suppression of analysis regarding 3I Atlas contradicts fundamental principles of scientific inquiry. We call upon all space agencies and research institutions to immediately release complete observational datasets and allow independent verification of findings. Major media outlets began covering the scientific controversy, though still with more attention to the debate than to the underlying evidence. Headlines focused on divisions within the scientific community, on clashing interpretations, on the personality conflicts between Loeb and his critics. The actual question of whether 3I Atlas was artificial got lost in coverage of the controversy surrounding that question. But public attention was shifting. Opinion polls conducted in late November showed that a majority of respondents in multiple countries believed governments were withholding information about 3I Atlas. Whether that information confirmed alien technology or simply revealed embarrassing institutional mistakes was debated, but the baseline assumption of suppression had become mainstream. The collapse of institutional authority on the subject was nearly complete. Agencies that had maintained unified messaging in October found themselves unable to control narrative by late November. The leaks, the amateur observations, the peer-reviewed publications, the open letters from scientists had overwhelmed the coordinated silence that had characterized earlier responses. On November 30th, under mounting pressure from media, from scientific community, from public opinion, NASA announced a press conference scheduled for December 2nd to discuss recent observations of interstellar object 3I Atlas. The announcement was brief, provided no details about what would be discussed, but represented the first acknowledgement that institutional response needed updating. The press conference would be the moment when institutions either acknowledged what the evidence showed or doubled down on denial despite that evidence. It would determine whether the collapse of institutional credibility was temporary or permanent, whether trust could be rebuilt through honesty or would be permanently damaged by continued obfuscation. As December 1st arrived, amateur observers continued tracking 3I Atlas as it moved into the outer solar system, now beyond Mars' orbit and heading toward the asteroid belt. The object was becoming harder to observe, distance reducing its apparent brightness. But careful tracking showed it was still maneuvering, still using propulsion to modify its trajectory in subtle ways. Whatever 3I Atlas was, wherever it was going, it remained active, operational, purposeful. And humanity, whether institutions acknowledged it or not, was watching the first confirmed artificial object from another civilization as it completed its survey of our solar system and prepared for whatever came next in its mission. The truth had escaped containment. The question was only whether acknowledgement would come through official channels or through the continued erosion of institutional credibility until denial became impossible to maintain. December 2nd, 2025, 15 Tak UTC. The NASA press conference began exactly on schedule, broadcast live across multiple platforms, watched by millions globally. The setup was formal, a panel of senior officials from NASA, ESA and JAXA, representing coordinated international response. Behind them, the agency logos, symbols of institutional authority that had governed space exploration for decades. Dr. Sarah Chen, NASA's Associate Administrator for Science, spoke first. Her opening statement was carefully constructed, each word chosen for precision, each sentence building toward acknowledgement that everyone watching had already anticipated. For the past 8 months, space agencies around the world have been observing an object designated 3I Atlas, the third confirmed interstellar visitor to pass through our solar system. Initial observations suggested characteristics consistent with cometary composition and behavior. However, as observation campaigns have continued, as data has accumulated from multiple independent sources, we have encountered measurements that challenge conventional interpretation. The language was bureaucratic, passive, designed to soften the impact of what was coming. But the direction was clear. This wasn't a press conference to deny artificial origin. This was preparation for acknowledgement. Dr. Chen continued. Spectroscopic analysis conducted by both institutional and independent observers has detected emission signatures inconsistent with natural cometary composition, specifically the presence of ionized xenon at concentrations and energetic states, not explained by known natural processes. Additionally, trajectory analysis indicates velocity modifications that cannot be accounted for through gravitational interactions or natural outgassing alone. She paused, allowing the technical language to settle, allowing viewers to understand what was being said without it being stated explicitly. Then came the sentence that would define the moment. Based on comprehensive analysis of available data, the consensus scientific assessment is that 3I Atlas represents technology of non-terrestrial origin. The room fell silent. Not shocked silence, the revelation had been expected, but the silence of confirmation, of something suspected finally being acknowledged, of institutional authority finally aligning with observable reality. Dr. Chen didn't stop there. We recognize that this conclusion has profound implications. We also recognize that the process by which this conclusion was reached has raised legitimate questions about transparency and communication. The delay in public acknowledgement resulted from institutional caution, from the extraordinary nature of the finding, and from recognition that confirming artificial technology from another civilization represents perhaps the most significant discovery in human history. That significance demanded careful verification. However, that caution should not have prevented more open communication about the observational campaign and the anomalies being documented. It was as close to an apology as institutions would offer, an acknowledgement that suppression had occurred, framed as protective caution rather than deliberate deception, but an acknowledgement nonetheless. The ESA representative spoke next, providing technical details about observations from Mars-based assets. The blurry October image was addressed directly. The initial release was intentionally low resolution. We had captured far more detailed imagery, but had not yet completed analysis sufficient to draw conclusions. The decision to release preliminary data without context was an error in judgment. Translation: they'd known in October that something was anomalous, had deliberately released poor quality imagery to avoid premature disclosure, and had underestimated how that decision would undermine credibility when better data eventually emerged through other channels. The JAXA representative discussed the xenon signatures in detail, confirming that ion propulsion was the most likely explanation, that the spectroscopic data was consistent with technological propulsion systems rather than natural processes. He presented spectra, showed comparisons to known ion drive emissions, demonstrated the technical basis for the artificial origin conclusion. Then came the critical question, posed by a journalist in the press room. If this is confirmed as alien technology, what does that tell us about its purpose? Why is it here? Dr. Chen's response was measured. We can only speculate based on observed behavior. The trajectory brought 3I Atlas through the inner solar system, past Earth and Mars, both planets showing clear signs of technological civilization. The timing, approaching during an era when we have capability to observe and analyze such visitors, suggests the possibility of deliberate survey or reconnaissance. The object has not demonstrated any hostile behavior, has not deviated toward planetary orbits, has maintained trajectory consistent with passive observation. Our assessment is that 3I Atlas represents an autonomous probe, likely designed to investigate stellar systems for signs of technological development. Another question: are we in contact? Has there been any communication? We have detected radio emissions at 1420 MHz, the hydrogen line frequency, during closest approach to Earth. The emissions appeared to carry structured information, though we have not successfully decoded any message content. Whether these emissions represent attempted communication with us or data transmission to another destination remains uncertain. No directed communication toward Earth has been detected beyond the presence of the signal itself. The questions continued, each answer providing incremental detail, building a comprehensive picture of what was known and what remained mysterious. Yes, the object was still operational, still maneuvering, still moving outward from the sun. Yes, trajectory calculations suggested it would eventually leave the solar system, continuing on interstellar journey. No, there was no indication of additional objects, no evidence of a larger fleet or follow-up probes. No, there was no immediate security concern. The object posed no threat to Earth or space-based infrastructure. One question cut through the technical discussion to the philosophical core. What does this mean for humanity? How should we understand our place in the universe now that we know we're not alone? Dr. Chen's answer was thoughtful, personal in a way that broke through the institutional formality. That's a question every individual must answer for themselves. As a scientist, I can tell you that we've confirmed what many have long suspected, that technological civilization is not unique to Earth, that intelligence emerged elsewhere in the universe, that we share the cosmos with others capable of understanding and exploring it. As a human being, I find that both humbling and inspiring. We are not the center of creation, but we are participants in something far grander than our individual planet. What we do with that knowledge, how we let it shape our priorities and choices, will define our species in ways we're only beginning to understand. The press conference continued for another hour, covering technical details, addressing concerns about security protocols and international coordination, discussing plans for continued observation as 3I Atlas moved into the outer solar system. But the essential revelation had been delivered in those first minutes. Confirmation that humanity was not alone, that evidence existed, that institutions were finally acknowledging what data had been showing for months. As the press conference concluded, reaction cascaded across media and social platforms. The story dominated every major outlet, pushed aside all other news, became the singular focus of global attention. Analysis, speculation, debate, all exploding in the wake of official confirmation. Religious leaders offered interpretations ranging from embrace to rejection, some seeing confirmation of divine abundance, others struggling to reconcile revelation with theological frameworks built on human uniqueness. Philosophers discussed implications for ethics and meaning. Scientists outlined research priorities for understanding the technology and perhaps eventually communicating with its creators. The reaction wasn't uniform panic or universal celebration. It was complex, varied, millions of individual responses to news that challenged fundamental assumptions while confirming what many had already accepted as likely truth. In amateur astronomer communities, the response was vindication mixed with frustration. They'd been right. Their observations had been accurate, their analyses sound. But institutional dismissal of their work, the months of suppression and skepticism, had damaged trust in ways that confirmation couldn't immediately repair. Avi Loeb gave interviews across major platforms, carefully avoiding "I told you so," while making clear that the evidence had been available far earlier than institutions acknowledged. His message focused on the need for reformed scientific culture, for openness to unconventional hypotheses, for courage to follow evidence wherever it led, regardless of how challenging the implications. As December 2nd moved into December 3rd, the world was processing revelation. Not the revelation that alien technology existed, that had been leaked and analyzed and debated for weeks. The revelation that institutions had finally acknowledged it, had finally aligned official narrative with observable reality, had finally chosen transparency over control. But acknowledgement of 3I Atlas's nature raised questions that had no immediate answers. Where did it come from? How long had it been traveling? What data was it collecting? Where was it transmitting that data? Were there others? Would there be contact, communication, eventual encounter with the civilization that built it? Those questions would take years or decades to answer, if they could be answered at all. 3I Atlas was moving away, becoming more distant and harder to observe. It might never return to the inner solar system. Humanity might never encounter its creators. The probe might be the only evidence we'd ever have that others existed out there in the cosmic darkness. But that evidence was enough. It was proof that the universe was populated, that intelligence emerged, that technology developed, that civilizations built things designed to outlast them and carry knowledge across the void between stars. On December 4th, amateur observers tracking 3I Atlas reported something unexpected. The object was changing course again, making a more substantial maneuver than the subtle adjustments observed during closest approach. Trajectory calculations showed it was no longer heading simply outward from the solar system. It was turning toward Jupiter. The gas giant sat in its orbit beyond the asteroid belt, massive and prominent, clearly visible to any probe surveying the solar system. 3I Atlas appeared to be adjusting trajectory for a Jupiter flyby, perhaps seeking gravitational assist to increase velocity, perhaps planning closer observation of the largest planet and its complex moon system. The maneuver suggested mission parameters, suggested the probe wasn't just passing through, but was conducting systematic survey, investigating points of interest, following a planned observation campaign rather than simply traversing on a ballistic trajectory. NASA confirmed the trajectory change, acknowledged that Jupiter flyby appeared likely based on current maneuvers. The encounter was calculated for late January 2026, approximately 2 months away. Space agencies were already discussing observation campaigns, coordinating telescope time, planning to document the flyby in far more detail than had occurred during Earth approach. The controversy over suppression hadn't disappeared, but it was being overtaken by excitement about what came next. 3I Atlas wasn't leaving immediately. It was staying in the solar system longer, providing additional opportunities for observation, for documentation, for understanding what this probe was capable of and what mission it was designed to accomplish. As December progressed, the world adapted to new cosmic reality. Confirmation of alien technology became background truth, something people incorporated into worldview, something that shaped conversation without dominating it. Life continued, changed subtly, but not fundamentally, by knowledge that humanity wasn't alone. Religious attendance spiked briefly, then returned to normal patterns. Stock markets reacted, then stabilized. Political debates incorporated reference to cosmic context, then returned to familiar territorial concerns. Humanity demonstrated remarkable capacity for absorbing extraordinary information and continuing with ordinary existence. But something had shifted permanently. Every person who looked at the night sky now understood they were looking at a place where others existed, where technology traveled, where intelligence persisted across unimaginable distances. The cosmos wasn't empty void, punctuated by isolated instances of life. It was populated, active, full of presence, even when that presence remained distant and mysterious. 3I Atlas moved outward toward Jupiter, carrying with it questions that might never be fully answered, but had already transformed human understanding of cosmic reality. The worst theory, the one suggesting artificial origin, had grown with each new image until it became undeniable truth. And humanity, watching that truth depart into the outer solar system, was left to wonder what other probes might be traveling through the galaxy, what other civilizations might be observing us even now, and whether someday contact might evolve beyond detection of distant machines into actual communication with those who built them. The investigation wasn't over. It was just beginning. But the central mystery, the question that had driven months of speculation and controversy, had been answered. We are not alone. We never were. And the universe, viewed through that knowledge, became something far stranger and more magnificent than isolation had ever allowed us to imagine.